data into decisions and insights into innovation. We recently celebrated World Statistics Day on October 20. We we continue the spirit of awareness and learning here today, recognizing the power of statistics as the foundation of data science and machine learning. A very good morning to everyone. I am Shaista Taranam, Assistant Professor, Department of Computer Science Engineering. It is my great pleasure to welcome you all to today's 3-day workshop on statistics in data science and machine learning. Ramaiah anthem embodies institutional identity and it encourages a greater sense of belonging within our university to demonstrate who we are and what we stand for. Ladies and gentlemen, I request you all to kindly rise up for the Ramaiah anthem.
सकलांतर्यामी हरिणी चाल भजितुम् ज्ञानं विज्ञानं च भक्तिसहितम् विनयभूषण रामय्य समूह संस्थान ज्ञान विज्ञान विद्या विनयभूषण रामय्य समूह संस्थान ರು ಕಟ್ಟಿದ ಕನಸಿನ ಸಾಮ್ರಾಜ್ಯವಿದು ದೀಪಗಳು ಪ್ರದೀಪಗಳ ಬೆಳಗುವ ಶ್ರದ್ಧಾ ಸ್ಥಾನವಿದು ಜಿಗಿಯುವ ಸಂಪನ್ಮೂಲವಿದು ತಂತ್ರಜ್ಞಾನ ಸೋಪಾನವಿದು ಜ್ಞಾನವೇ ಸಾಧನ ಕ್ಷೇತ್ರವಿದು ಪ್ರತಿಭೆಯ ಸಾಧನೆ ಮಾಡಲು ಸ್ಫೂರ್ತಿಯ ಕೇಂದ್ರವಿದು ಅಜ್ಞಾನದ ಕತ್ತಲೆ ನೀಡುವ ಸುಜ್ಞಾನದ ಸೂರ್ಯನ ರಶ್ಮಿದು
Now be seated. We are truly honored to have with us a distinguished gathering of dignitaries. Dr. R.P. Suresh, former Data Science Principal Director, Accenture Analytics, Bangalore. Dr. Sarat Kumar Maharana, Dean Ramaiah Technology Campus. Dr. Nayana Patil, Associate Dean Ramaiah Technology Campus. Dr. Somshekharji, Professor and Head, Department of Mathematics and Statistics. Dr. Jyoti A.P., Program Head, Department of Computer Science, Program Head, Mathematics and Computing. I request all the dignitaries to kindly grace the dais. Please give a warm welcome to all the
ईशावास्यमिदं सर्वं यत्किञ्च जगत्यां जगत् तेन त्यक्तेन भुञ्जीथाः मा कृतः कस्य स्विद्दनम् यं ब्रह्मा वरुणेन्द्ररुद्रमरुतः स्तुवन्ति दिव्यैस्तवैः वेदैः साङ्गपदक्रमोपनिषदैः गायन्ति यं सामगाः ध्यानावस्थिततद्गतेन मनसा पश्यन्ति यं योगिनो यस्यान्तं न विदुः सुरासुरगणाः देवाय तस्मै नमः देवाय तस्मै नमः देवाय तस्मै नमः. Thank you.
Thank you, Shishir, for your soulful invocation. Light symbolizes knowledge, positivity, and progress. To mark the formal beginning of this workshop, I invite the dignitaries on the dais to kindly join together for lighting of the lamp. I request you student participants and faculty members to join the dignitaries, please.
Yes, go.
Thank you everyone for illuminating the occasion. I now request our Dean Sir Dr. Sarat Kumar Maharana to kindly give a floral welcome to our today's chief guest, Dr. R.P. Suresh. A warm welcome to you, sir. I request Dr. Nayana Patil to kindly give a warm welcome to our Dean Dr. Sarat Kumar Maharana.
Thank you.
I request Dr. Somshekhar to kindly welcome our Associate Dean, Nayana Patil ma'am. I request Dr. Jyoti AP to give a welcome to Dr. Somshekhar. And finally, I request Dr. Ms. Madhushri to kindly welcome Dr. Jyoti AP. Thank you everyone. To formally welcome the gathering, I now invite Dr. Jyoti AP, Workshop Coordinator, Associate Professor and Program Head of Mathematics and Computing to deliver the welcome address. Over to you, ma'am.
Good morning everyone. I am Dr. Jyoti AP, Associate Professor and Head Mathematics and Computing Program from Department of CSE. So it gives me an immense pleasure to have you all here and to extend a very warm welcome to each and every one of you on behalf of Faculty of Engineering and Technology, MS Ramaiah University of Applied Sciences. So we are gathered here today to inaugurate the 3-day workshop on statistics in data science and machine learning, organized jointly by Department of Mathematics and Statistics and Mathematics and Computing Program. So on the special occasion of World Statistics Day. So at the very outset, it is my great honor to welcome our chief guest, Dr. R.P. Suresh, former Data Science Principal Director at Accenture Analytics, Bangalore. So we are deeply grateful that you accepted our invitation to grace this event. Thank you very much, sir. Your vast experience in applying data science and analytics to real-world business problems will surely inspire all participants and provide deep insights into the fusion of statistics, machine learning, and industry innovation. I also take this opportunity to extend a warm welcome to all our distinguished resource persons from eminent institutions, Dr. Kanta Rao, Principal Scientist from CSIR, Dr. R.P. Suresh, just now I introduced him, and Dr. Sudesh Kumar K. He is Associate Professor from Indian Statistical Institute, Chennai, and S.Y. Babu, General Manager, Technical Leader, Global Data Insights and Analytics, Ford Motor Company, Chennai, and Dr. R. Vishnuvardhan, Professor, Department of Statistics from Pondicherry University, and Dr. Deepak A.S. from Manipal Academy of Higher Education, Bangalore, and we have Gangadhar Sir, Jyoti AP, and also Subramania Sir from MS Ramaiah University of Applied Sciences. So we are very honored to have such an eminent lineup of experts who will guide our participants over the next 3 days. So I take this opportunity to welcome all the participants in this event, faculty, researchers and students, both online and offline. A special welcome to our beloved Dean, FET, Dr. Sharat Kumar Maharana Sir, and Associate Dean, FET, Dr. Naina N. Patel. Without them, this program wouldn't have been successful one, I suppose. So thanks a lot for supporting us. And I extend a warm welcome to our respected HOD, Dr. Somashekara Ji, HOD of Mathematics and Statistics Department, and Ingi Sharma Madam, HOD of Computer Science and Engineering in her absentia, and all other HODs and faculty members of RUAS who have assembled here to be part of this event. This workshop is a true reflection of our university's interdisciplinary ethos actually. So blending mathematical foundations, computational skills, real-world applications. So in today's digital world where decisions are increasingly driven by data, the role of statistics have become really very much critical than ever. So it serves as a bridge between the raw data and the meaningful intelligence, enabling the design of robust models, reliable predictions, and responsible decision making. So being an organizer of this workshop, I also take this opportunity along with Dr. Subramania Sir to thank the efforts of the dedicated team of faculty members from both the departments. So Dr. Anupriya Jha, Dr. Sandeep Kumar, Dr. Pritam MP, Dr. Manohar and Akash from Department of Mathematics and Statistics, and from Department of CSC, Ms. Shaista Taranum, Ms. Padma R, Pranita, Padushri and Shilpa from CSC department for meticulously planning and showing their commitment in organizing this workshop as coordinators. So their collaborative effort and spirit beautifully represents the synergy between the mathematics and computing at RUAS that we are having event today. So over the next 3 years, you will gain valuable technical insights into statistical thinking, machine learning and data science. So we will be learning about tools like R and Python also. And I am confident that this workshop will serve as a powerful platform for knowledge exchange, new collaborations and innovations, reinforcing the RUAS commitment to the academic excellence, research and industry relevance. So once again, I warmly welcome our chief guest, resource person, dignitaries, faculty, students and participants. So let us look forward to 3 enriching days of learning and interaction. Happy learning and wish you the workshop a very great success. Thank you.
Thank you, ma'am, for your warm welcome and inspiring words. We are privileged to have with us Dr. Sarat Kumar Maharana, Dean Ramaiah Technology Campus. I request her to give the opening remarks.
Suresh sir, our guest, thank you sir for joining. It's a pleasure. I welcome you to this campus. My colleagues, the dais, of the dais, beloved students. First students are there, so I welcome all of you to this 3-day workshop. This title was well thought after a few discussions with our head of the Department of Mathematics and Jyoti Madam that you will put data science and machine learning. Department of Mathematics conducted one FDP very recently, a month ago. It was in a dark room, very secret. I will tell you a good thing, don't worry about it. See, knowledge, the beautiful things in the world are free, you know that. Air is free, you don't buy air, right? So, of course, we are buying water. So, if the energy, if the data science, machine learning is so important, why are you keeping in a dark room? Why don't you open it up to the whole world? I think due to which you are all sitting here. I also spoke a few lines in the opening ceremony. There is a small room, 30-40 members are sitting. Thank you so much, both of you, to bring this to this. Particularly, I thank Jyoti ma'am because she has lent her hand to this mathematics and computing. It was more of mathematics. We said our students do not understand the application of mathematics. Probably these two have come very, very nicely. Before I proceed further, I have few words to speak and then I will leave to our dais, to our guest very soon. Recently, I was just reading about some article that everybody dies. Everybody dies, even the stars also die. Then whoever has come to this earth, everybody will die. Yes, that's true. The light never dies. The cosmic rays never dies. The energy, that is the energy, it will not die, it will not be created, not destroyed. So light never dies because it's energy. Stars have died. Now, why I am saying this? If you look at this machine learning, it is not dying. If you look at all the tools, machine learning tools that we are using on a daily basis, in profession, in personal life, it is not going to die anymore. We may not be there, but it will not die because we are putting a lot of energy into it and it will never die. So I request the participant to make sure that it never dies. It is sustainable, it will be renewable. So you will be renewing this machine learning algorithms so well that it never dies. The significance of this data science and machine learning reminds me a lot of things when I started doing this research thesis, PhD thesis for some of our students who got PhD 5 years back. It was at infancy stage. We are trying to set, for your information, you are the big hot seat, so in the companies, in the academic setup, we don't do much because we don't have big computer, a small laptop with small memory. We don't know how to do it. So the research scholars were using small data sets, very 300 to 400 observation samples, so very small amount. But they were excited when the thesis was accepted with few around 50 to 70 pages. Why? Because machine learning has come for the application to very specific composite materials. Mechanical engineers are not here. Composite materials. Recently, the graphene oxide, where we started using it. In fact, there we got to know that machine learning. This is machine learning. Then what is data science then? Machine learning, data science. Are we mixing them or they are separate? They are actually separate. We must visualize the data, understand, bring some science, then we put the learning. The learning never comes unless we understand the science. And beautifully it has come. So, most of the application side, if you look at it, first you have to visualize, see, okay, I am happy or not happy, I will do this, I will not do that. Everything comes next. So, in our curriculum, if you look at our curriculum, we have thoughtfully designed the curriculum in such a way that all our programs, there are 6 departments, prominent departments: civil engineering, mechanical engineering, algorithm will be same. Data sets are different. Computer science data sets will be different. Electrical EC are different, but the algorithms are same. Now, this machine learning algorithms, when you use for different domains and applications, you have to think the science of it. And before you start applying, we must visualize it, unless you visualize, you cannot take a decision. So these two have come very well. Now recently we have added a beautiful feather in the cap is quantum computing. Dr. Gangadhar will be speaking about that. And why quantum has come in between? It is not in between. It's a baby now entering into, it's a cradle now, it has to come out to this campus, it's just entering. Now that machine learning is a little matured, we understand it a little bit, we breathe it, we speak about it. But unfortunately, the machine learning algorithms are not understood. Just ChatGPT copied reports are coming to us. Very unfortunate to mention this. Most of the algorithms our students use, our faculties use, directly come from the Python code that are run directly in the IDE, and the results comes to us without interpretation, without understanding why, what is the average, what is the standard deviation. If the standard deviation is not understood, if the age and values are not understood, then what is the fun of learning the machine learning? We have not understood what is age and value. We do not know age and vector. We do not know support vector. We do not have the clue about this. Recently, I had a discussion about what is singularity. Recently, I was talking to one of our faculty members. Unstable singularity. You speak about singularity. This is also discussed in machine learning. Why are you not teaching the singularity to our students? Equilibrium. Simple equilibrium. It is an unstable singularity. So these thoughts have not gone into the young minds. I request the speakers to think about the fundamentals rather than talking about bigger things. I essentially request Frisha to bring some light to us that how these simpler things, the fundamental things, make this world so beautiful of data science and machine learning. Thank you so much. Have a wonderful session. Thank you.
Thank you, sir, for your motivating address. We are honored to have with us our chief guest, Dr. R.P. Suresh, former Principal Director of Data Science and Supply Chain Analytics at Accenture Applied Intelligence, Bangalore. Dr. Suresh has over 30 years of experience across academia and industry. He has served as a professor at IIM Kozhikode and held positions at General Motors R&D, University of Pune, and MS University of Baroda. He was also the visiting professor at Victoria University of Wellington, New Zealand. A respected researcher, Dr. Suresh has published more than 30 papers in international journals with over 400 citations and is recognized for the Kiko-Suresh method in statistical estimation. His work in reliability modeling and analytics innovation has earned him honors including GM R&D Innovation Award, GM India's President Honor, and the Best Young Statistician Award from the Indian Society of Probability and Statistics. We are privileged to have you with us, sir. Please keep it down. I now invite Dr. Suresh to kindly deliver the keynote address.
Thank you so much for your introduction. It was it has been indeed a pleasure to visit MS Ramaiah Institute. I visited MS Ramaiah Institute of Technology a few years back, about a decade back. And so it's been, this campus has been very beautiful and much more interdisciplinary activities take place here, particularly here. I'm happy to meet some of the senior colleagues here, and Professor Gangadhar, Professor Sarath, and all of you. It's very interesting to know how you make the learning a very big experience, very good experience for the students, because the way you are committed to learning, you will naturally make the learning much easier for the students. And in fact, I definitely, continuing with what Dr. Sharath had mentioned, so machine learning never dies. In fact, more generally, learning never dies. Knowledge never dies. In our ancient, if you look at all these Purana and what is that? So your body may leave the soul, your body may leave this one, may die, but the knowledge that you have will get transferred. And that is our principle. That is that you can see that knowledge never dies because it keeps developing, it keeps innovating itself, and that is the reason for all that. Today we may have different innovative solutions for medical healthcare, for computing, for mobility, for communication, and all of this. All this is a generation of people contributing to that. So it is not just that any one person getting a home Nobel Prize today is a major contribution for all of this. It's a generation of people contributing and people picking up from there. The knowledge remains and then it keeps developing. So I think that's exactly what we believe in, and that's what is happening also. And so in that sense, machine learning is what we try to sort of feed to the machine. So right, in the sense that what extraction do we get from the data? Right? So that's where machine learning is related. So, but how does a machine learn? It learns from the data. So what data do you feed it? I mean, that's what the initial this one people talk about in computing, right? Garbage in, garbage out. So it depends on what you feed it. So what you can feed in, what is the data? So what you can extract from the data? How do you provide the data? How do you clean the data? How do you take the essential things in the data? Now, one simple example I give you is that when I was working at Accenture. So some of my colleagues, so we used to work for different organizations. I mean, right from Walmart, retail company, to some of the leading telecommunication companies and some of the oil industries and so on. So many companies we have consulted. Almost all Fortune 500 companies Accenture has been consulting. And we had one of the companies which wanted particularly a retail company, which is a famous retail company in Europe. They actually sell what is called as the DIY, do it yourself. There is something like this, what we buy in the infrastructure, gardening development, and all these equipment that we use for electrical equipment and all. So basically anything that we can do ourselves. So unlike India, if you have some problem with the plumbing or electricity, you just call a plumber and they will take 100 rupees and solve it and go. In Europe, it's not like that. You need to pay $100. So instead of that, people do it themselves, including all kinds of gardening and household activities, everything. So they have. It is something like our metro cash and carry. It's there in Yashwanthpur, right? So that kind of a store where you have huge store, a retail store, everything comes and picks up a lot of things like that. So our model, so we developed one of our first, that was one of the first projects for a new joiner. So he used a machine learning model, something neural network or something. He just decided. He said this is the forecast. So he just, and then I looked at it and then I said that okay. So he said that for a particular product, he said the product this one is going to go up. We have the board here, right? Anyway, I'll not take maybe I'll more details in the regular session. But so what happened is that the prediction was that based on for 2023, he predicted a huge sales for a particular product. Now what happened is that if you particularly look at it during the COVID period, everybody started managing their home themselves. There's literally for anything you used to go out. Like most of the things you do it yourself. So therefore the do-it-yourself sales were very high during that time. 20 and 21 it was too big. But 20 especially it went down because people were too much afraid to do anything. It was a fear factor which was going all over the world. It's not only in India, everywhere. Right? And 21 people started slowly coming out. So 20 to 21 the jump was quite high. 21 to 22 again it was much. And then 22 onwards. So based on 20, 21, 22 averages or anything like that, 3 yearly moving averages, it actually projected for 24 and 25 very high sales. But literally it didn't happen because things came back to normalcy. In 23, 24, things came back to normalcy. The sales didn't go up so much. So the reason was that. So this is where you need to properly put in your what you call as sensitize your. I mean sort of explain the data peaks, explain the data variabilities. So we know that all these peaks that happened in 2021-22 is all due to the close down of the many shops and COVID pandemic and all of that. But post that it was coming up. So we have to look at the latest trends in 23 and then recalibrate our forecast. This is where statistics is required. So you need to bring in what kind of additional factors that are coming in, what kind of additional variables that you need to involve in. For example, similarly, if I look at the last 2 days in Bangalore and today's weather, you can't predict it. Right? So you need to sort of look at what is the kind of it is maybe happening because of some pressure that is happening, some depression that is taking place. So you need to understand a lot more of factors. Identifying what factors are important is again a kind of insight that statistics can bring in, and then you use these machine learning to bring it. So that's where statistics is something which gives a lot of so, and people are talking about explainable AIs, because AIs generally throw you some data based on some output based on the data, like what our professor mentioned, that you give some forecast, you give some predictions. Whether these predictions can be explained. Another client which we had, wherein we created a kind of a forecast, we developed a forecast, and then they found that these forecasts were very much away from the target for previous. So we were trying to look at, again, that's again machine learning. So we want to look at for the last week's forecast, what was the difference between actual and forecast? Where have we gone wrong? We need to learn that. Why is it not improving? Right? So this is how we try to improve that. So that time they were asking why is that we are not able to predict it properly. Then we had to find out and say. So for example, for certain products, there was a few years back in 23, 22, end of 22 or something, there was some some problem that happened in the Black Sea. So there was some transports were affected and all of that. So because of that, a lot of supplies were affected. Because supplies were affected, demand was affected. Because sales cannot take place if there is no supply. So there were a lot of such reasons we need to understand. Similarly, in US, when there is some storm somewhere happening, these days, many of these cyclones are given different names. I don't remember the name of that. In 2013, there was a cyclone that happened in US, and in one part of the US, and because of that, the supplies got, because once the the most of the supplies to US were taking place from China, India, Indonesia, and all of the Asian countries through the sea, through the water. So because it has reached the the ports, seaports, but it could not reach the land. So because of which, even the Christmas Day sales were affected during that time. So that happened in November 2012, and 2012 December sales were affected because supplies could not take place. So as a result of all, because in US people have a habit of start purchasing for the Thanksgiving days. It happens at the end of November. So the whole month, so they start preparing for the Christmas. So therefore, in November, 1 month, if the problem happens, it actually affects the customer. So we need to explain why certain things are happening. So we need to look at the data, we need to look at the corresponding coordinates, how each coordinate is contributing to that. This is where you need a lot of insights that can be generated using statistics. So statistics in data science has been, in fact, at the end of the day, what is data science? Anyone who wants to? Any thought about what is data science? As Professor Sharath also mentioned, data science is actually generating insights, generating science out of what the data tells, right? Extracting data and generating insights from it. So that's where we need to look at, and statistics is, what is statistics? It's a science of collecting data, it's a science of collecting information and then analyzing and then interpreting. Right? So the kind of inferences that you generate out of data and say that what is actually contributing to certain factors will actually improve the machine learning part of it if you incorporate it. So a joint workup, and I would say that, to a large extent, maybe I am totally biased towards that. I would say that statistics is the mother of data science. Statistics is the mother of computing. In fact, statistics along with mathematics, these are the joint parents of computing. I'm sure all of you would agree to that, right? So it actually feeds into that. Like you can. So from mathematics is the mother of computing. It is the mother of statistics actually. Mathematics is the mother of statistics. In fact, I used to have a professor. I don't know how many of you have heard about it. Professor Pakshirajan who was a professor in Mysore University, who was my professor. So I was doing MSc there. So he used to say that statistics is nothing but mathematics. The only difference that happened is that while mathematics uses the equations and comes up with certain theorems and proofs and saying about what are the functional relations between the different variables, etc. Statistics try to put it in terms of acceptable and understandable things. For example, regression analysis is definitely a mathematical concept, but bringing it into a scatter plot and explaining to the people about why certain things are happening is where statistics is needed. So the statistics brings up that explanatory approach to the data. Right? That's what it brings in. So it brings in inferences, it brings in all of these different add-ons to the data, making the machine learning concept much easier and much more scientific in nature. So that you can incorporate those insights into it and make more learning out of it. That's the idea. I think if that's this is a short initial introduction I have. We will have more details about it in the session. Thank you so much.
Thank you, sir, for your thought-provoking address. I request the dignitaries to kindly felicitate our keynote speaker.
All this not required.
Looks so nice. Somebody come
Thank you, everyone. I now invite Dr. Naina N. Patil, Associate Dean, Ramaiah Technology Campus, to address the gathering.
Thank you. Namaskara and a very good morning. I really thank Suresh ji and our Dean sir for addressing the gathering so well. And it feels too good to be among statisticians in the occasion of celebration of World Statistics Day. And as you are aware, World Statistics Day acknowledges the importance of high quality, reliable statistics and data in global and national development, policy making and informed decision making. Celebrated every 5 years on October 20th, it highlights the role of statistics in areas like healthcare, education, economics, environmental protection, and it also serves to showcase the achievements and foster cooperation within the statistical community and raise public awareness about the importance of data. Statistics is important in daily life. It helps make sense of data and it helps in taking informed decisions, understand trends in areas like finance, weather, and also different government related activities, from checking weather forecasts to managing personal finances and understanding how diseases spread. Statistics provide tools to analyze information, make predictions and assess the risks. please understand, everything is raw data, everything is plain until it meets statistics. Statistics gives sense to data. Why is statistics making such a noise of late than ever? Statistics provides the foundational mathematical principles for data science and machine learning, enabling data analysis, pattern recognition, and prediction. It also plays a key role in summarizing and visualizing data, quantifying uncertainty, validating models, and so on and so on. While statistics focuses on making inferences about a population for a sample, machine learning focuses on finding generalizable patterns to make predictions. And what is data science without statistics? Without statistics, data science is significantly limited and would lack the ability to properly interpret data, validate findings, or build reliable models. So statistics is very important even for data science. Next, what about machine learning and statistics? Machine learning can exist without a deep understanding of statistics, as it can be treated as a set of algorithms that are trained to make predictions, but it is impossible to have effective machine learning without statistical principles, because statistics provides the foundational theory of how algorithms learn from data and build predictive models. The workshop on statistics in data science and machine learning is really wonderful. I thank all the resource persons for consenting to be a part of this FDP. Wish all the participants a happy learning, and I congratulate all the coordinators for their extreme efforts in celebrating this day as well as organizing this function. Thank you one and all. Jai Hind, Jai Hind.
Thank you, ma'am, for your constant support and guidance. We now move on to the next part of the program. I invite Dr. Ramaiah, Workshop Coordinator and Assistant Professor, Department of Mathematics and Statistics, to brief us about the objectives and highlight us about the 3-day workshop. Over to you, sir.
Thank you, madam. Respected dignitaries and the dais, my dear participants, faculty colleagues, and my students, a very good morning to all of you. Today we are gathered here on the occasion of 3-day workshop on statistics in data science and machine learning. This workshop is organized to celebrate World Statistics Day and to explore the crucial roles of statistics in modern data-driven fields. So this World Statistics Day is celebrated every 5 years on October 20. It recognizes the importance of statistics in shaping societies through data-driven decision making, policy formulation, and sustainable development. So this World Statistics Day was announced by US Statistical Commission in 2010, and for every 5 years we are conducting this one. And this 2010 is the World Statistics Day year. And after 5 years, this is the fourth time this World Statistics Day is organizing globally. And as of 2010, 103 countries celebrate a National Statistics Day. So other than this globally, this World Statistics Day, so National Statistics Days are celebrated in all the countries. So in India, we celebrate on June 29th. Actually, this workshop was planned before June 29th actually. We have planned for National Statistics Day. Then after that, we have planned, after discussion with our dean sir and all. So together with World Statistics Day and the National Statistics Day, we have June 29th, we are conducting as a National Statistics Day on the occasion of the statistician P.C. Mahalanobis. Actually, we are calling as P.C. Mahalanobis is the father of Indian statistics. So, and this is the first time we are organizing a workshop in connection with World Statistics Day and National Statistics Day at our university under the valuable guidance of our respected dean sir.
we sincerely thank you, sir, for your continuous guidance and encouragement and support in making this workshop possible. So, in the era of massive data generation, what is the power of the analytics? This is the question. So, here is storage capacity or computational speed, or what is else? Because maybe storage capacity, you can store the massive data, and also computational speed, maybe you are calling now the speed is required more because data is more. And what else is required? So the third one is the logical framework that transforms raw data into meaningful insights. That is the statistics. So statistics is not only a collection of formulas and tools. It is a way of thinking, a logical framework that guides how we collect the data, we summarize the data, and we interpret the data and make inferences from the raw data. So the statistics forms the backbone of data science and machine learning, providing the foundation for understanding data, drawing insights, and driving innovation. So this workshop highlights the vital role of statistics in these fields and explores its profound impact on modern technological advancements. So I am very happy to announce that our workshop registrations have officially reached 175. So thank you very much for your amazing support. So I hope all of you will enjoy these sessions and gain meaningful insights you can carry forward in your future endeavors. Thank you very much.
Take this opportunity that registrations have come not only from Bangalore or Karnataka, from across India, and also at the international level we have received the registrations. I'm very happy to share with you all about this.
Thank you, ma'am.
Thank you, sir, for outlining the purpose and scope of this workshop. To conclude the inaugural session, I now invite Dr. Somshekhara Ji, to Professor and Head, Department of Mathematics and Statistics, to deliver the vote of thanks.
So before that, I have a question. What is the mystery behind 175 police station?
Online offline border.
So you will not tell me. Very good, thank you.
So, dignitaries on the dais, colleagues, friends, and dear participants, good morning all. Once Peter Block said, learning and performance will become one and the same thing. Everything you say about learning will be about performance. With this, I would say that learning enables us to perform better. With the initiation and support of our team, Dr. Sarat Kumar Maharana, the Department of Mathematics and Statistics has launched a series of workshops on data science, machine learning, and quantum computing in collaboration with the Department of Computer Science and Department of Physics. Recently, we have successfully completed 3-day workshop on Python Foundation for Machine Learning. In continuation, we are conducting this workshop. It's an honor for me to propose a vote of thanks on behalf of the Department of Mathematics and Statistics and Math and Computing Program, Department of Computer Science. To begin with, I would like to thank our today's chief guest and speaker, Dr. R.P. Suresh, former data science principal director, Accenture Analytics, and professor of practice, for giving such an insightful talk. We are really enlightened with your talk, sir. Thank you, sir. Now I would like to thank our Honorable Chancellor, Dr. M.R. Jairam, a visionary leader and an educationalist and philanthropist, for his immense support in all activities of RUS. Next, I would like to extend my heartfelt gratitude to our Honorable Vice Chancellor, Professor Kuldeep Kumar Raina, for his continued support and encouragement. I also extend my gratitude to our Provost, Professor Rangnath, for his support in all our academic activities. I thank our Registrar, S. Ashok Rao, sir, for his support and motivation in conducting all the activities of the university. Now I extend heartfelt gratitude to Dr. Sarat Kumar Maharana, sir, Dean RTC, for his support and constant guidance to organize this workshop. Sir, your vision and leadership continues to guide us, and your presence today adds an immense value to this event. Thank you for being a constant source of inspiration to both students and faculty members at RTC. Once again, thank you, sir. Next, I take this opportunity to thank Dr. Naina Patil, Associate Dean RTC, for her support and involvement to organize this workshop. Thank you, madam. I thank Dr. Rinki madam, Professor and HOD, Department of Computer Science, for her support in conducting this workshop jointly with the Mathematics and Computing program. I would like to thank Dr. Jyoti AP, Program Head and Organizing Coordinator, Math and Computing program, for her support in conducting this workshop jointly with the Mathematics and Computing program. I also thank the Organizing Coordinator, Dr. Subramaniam sir, Dr. Jyoti AP, faculty coordinators and student volunteers who have been working hard since from past 2 weeks to organize this workshop. My heartfelt thanks to the HODs of various departments and the faculty members for their encouragement in all our efforts. I would like to express my sincere gratitude to all our speakers for accepting our invitation to deliver a talk and all the participants of this workshop. I would like to thank today's master ceremony, Ms. Shaista Tanam, for wonderful anchoring. Thank you, Mr. Shira, for beautiful invocation song. I express my grateful thanks to Mr. Rajesh, Lohit, Mr. Deepak and team, ICT Nagaraj sir and team, all our support staff. Once again, I thank you, one and all. Jai Hind. Thank you.
Thank you, sir, for your concluding remarks. And thank you all the dignitaries, faculty members and participants for joining us today morning. We look forward for engaging and enriching sessions over the next 3 days. I request everyone to kindly rise up for the national anthem. Thank you, everyone. We now break for tea and we will be starting the session after the tea break. I request all the participants to kindly assemble. 11:45. I request all the participants to be here by 11:45. We will be starting the session. We will be having a session on statistics by Dr. R.P. Suresh. Thank you, everyone. Welcome back everyone. We now begin our session 1, Statistics in Data Science and Machine Learning. This session will be conducted by Dr. R.P. Suresh, former Data Science Principal Director, Accenture Analytics and Professor of Practice, Vidyashilp University, Bangalore. Sir will be sharing his expertise on how statistical concepts form the backbone of data science and their role in building intelligent and reliable machine learning models. I request Sir to start the session.
Still say good morning. Yes, 11:59. So, this has been an interesting journey, statistics and the current era. The statistics has been there ever since any kind of measurement has taken place. I mean, the first kind of statistics and inference, all these things started when people used astronauts and astrophysics and all of that. When people tried to find the distance between Earth and Moon and all of this. Where it's a very clear example where you cannot have a population values. You don't know what is the distance. You need to estimate it, right? So that's the first kind of published data where people sort of measure the kind of distance based on what you can see in the telescope and all of that, right? So that is where it all started, how it started. So this is how the reality is. I mean, you really don't know about a population. Any population you take, many times we don't know. For example, give a simple example about, let's say the demand for a particular product, right? Demand for a product. We don't know how much is going to be the exact demand. Be it you may be a retailer like Walmart or Big Bazaar, Smart Bazaar or whatever, things like that. You keep so many items on the shelf, and how many of them are going to be demanded in a day, and whether all of them will remain sort of in the shelf at the end of the day, or how many of them will be sold, how many of them do we need to replace, what should be our replacement strategy, all of this depends on variability. There's variability in demand. And there are different kinds of variability that exists for different reasons. There is, for example, for clothes, particularly cotton clothes, there is variability. Shirts and all is used more in cotton shirts, used more in summer. Winter clothes are used in winter. So we know that there are seasonal products. There are sometimes, there are some products which are non-seasonal, particularly the food items, the groceries, the vegetables and all of that. This is like, more or less available and required throughout the year. So there are, and again there are some, peaks and lows in different, for example, if I look at a retail store, month beginning there will be, a lot of sales happening because people go on after the salary comes, you go and buy the groceries and food stuff required for you, etc. Whereas after a while you try to sort of, unless it is what is required only, you go and buy there, only once in a month you visit. And in this kind of a Bangalore traffic, you can't go every day either, right? You're coming to Ramaiah school itself is a very big thing. So therefore, it is a very big problem. So we need to understand all of that. And now, so statistics has gone through ages. It has in the early centuries where people were developing models, mathematical models, right? For example, you can look at how it all. For example, we were talking about properties of estimators. Estimates. What are the estimates? For example, we want to estimate what will be the number of customers in a retail store. Number of seats which will be reserved in an aircraft. For example, between Bombay and Bangalore, whether how many seats will be sold, because all these just that today's how are these different airline operators work, because they have a variable pricing. Like, they start with, depending on the demand, they increase. So for example, recently it happened, I was, someone called me to visit, 3, 4, 6 months back, someone called me to visit Varanasi University, BHU, Varanasi, where, I saw, we have been sort of, thinking about what day to go and all that, because that time this Kumbh Mela was going on, so we want to avoid that, because there's too much rush there, we want to go beyond that. So that time we were trying to look at, when I looked at it in the January end, the prices were something like 7,000, 8,000 like that, for March 1st or 2nd week. When they started somewhere around, February 1st week, it started up to like 15,000. So that, these are the kinds of things that is happening. So to estimate the number of customers that is likely to be there in a particular day. And then what I noticed very surprisingly was that, I booked my ticket, then some of my family members also told, we will also come because we have not seen Varanasi and we want to also go and visit Prayagraj and all of that. By the time luckily Kumbh Mela was over, so we said we're safe to go there. And then we found that the prices have come down for 1 week, just 1 week was there. So now what is happening here? So you see that the price is a variability. It depends on several factors. It depends on, people who wanted to go, and then there are some negative things that people were saying that it's all dirty water, don't go there and all of that, then people stopped going. So this is a kind of a phenomenon that is happening. So so estimation is the most important. So what you do is that you always do an estimate. Very simply, even we estimate when you drive a car or you cross the road, you make an estimation. Like, when you are crossing the road, so there is no vehicle that is coming this side. There may be some vehicle coming that side, but then the speed of that vehicle is something like it may take another few seconds to reach here. So you make that estimate and then you cross it. Every one of us does, even dog does. Right? Even animals do. The dogs on the road, they wait very patiently. Bangalore dogs. They're very clever. So estimation is very much part of our life, all of our life. And then, another important thing that if you look at the businesses, okay, we estimate, but our lives are important because we make an estimate across the road or put our acceleration in the car, thinking that vehicle may take more time to reach us. If our estimation goes wrong, what happens? Our life is gone. Right? So there is risk involved over there. So we need to minimize the risk. So we need to see whether the hypothesis that we are talking about, that it is going to take 15 seconds for that vehicle to reach here. That is the hypothesis you have. Is it going to be less than that or more than that? That's where your hypothesis testing comes into picture. Right? Many times we don't do that, but we sort of take it for granted. We know that. We are estimating ourselves and say that no, there is no. Sometimes when we have a doubt, right? Suddenly when we put one step and see that no, that it is coming fast, we reject the null hypothesis, came back. Right? This has happened for all of us. So how do we decide all that? That is where statistics comes into picture. And there are a lot of properties of estimates that are there. Like for example, when we estimate, so you have a small sample size. You have a sample size. What is the sample size here? Like as I told you, population is unknown, but we need to estimate based on a sample that we get. For example, we all sitting here in the front benches decide about whether you are eligible to pass the course or not, based on the 2-hour exam that we take. We test the knowledge that you have in that subject based on the 2 hours. That's a sample. Right? And that is where, so you have to make your sample representative of the knowledge that you get. Right? So the question paper that we develop will have to be testing that knowledge, minimum knowledge that is required to call you a graduate in whatever. Right? So that sample has to be representative. And it has also got to be unbiased, random. So it should not be really looking at only. So there are certain skill sets that is required, right? So certain skill sets that are required. So you need to sort of see that whether all the skill sets are essentially incorporated in that testing process. That's why the current situation is that don't depend on one exam, have a continuous evaluation, right? So therefore you have more sample to know about that person's knowledge, the person's commitment to the subject, the person's understanding of the subject, etc. Right? So that's where, so one of the theorem that happens is that as sample size increases, your estimate goes close to reality. Right? So I have an estimate, let me call theta as an estimate, as a parameter. This is a parameter of interest. This could be, for example, the mean income of a particular place or location, right? Income of a small housing locality, right? This could be average income. So you estimate, how do you estimate that? You take a sample. You take a sample, maybe about 100 people, 200 people, 300 people. Let's take you take a sample of 100 people. So n equal to 100, and you estimate it based on that. So it could be the average of that. Of course, you need to ensure that these 100 people are representatives of the population. Like for example, if I take all IT people, then I am overestimating. If I take all people working with me in the industry here, then this is a place of industries, right? So you see that the workers, they may be hardly getting, their salary structure is much less than what you see in the IT sector. So therefore, if I get all 100 people are from this place, then my estimate is going to be wrong, right? So I do all of that. So then I need to understand what are the kinds of segments that exist in the population, or what kind of strata that exists in the population. That strata could be, for example, it could be in terms of that working something like blue collar workers, white collar workers, business people, etc., etc. You look at all of that. And suppose I have a certain percentage of people, like the segment is like that, like IT sector contributes to 30% segment, the blue collar workers contribute to something like 40% segment of this 40% of this whole population. Then my sample also should reflect that, so that I have an unbiased sample. That is called a stratified method of sampling. Stratified sampling. So there are different methods and all of that. So if I estimate that, what is my objective in doing this estimation? This estimation should more or less, on an average, prepare this. On an average, should be close to this. Because I am going to see, one of the applications of this estimating income is that I want to work, for example, I want to open a, let's say, Audi car showroom here. First thing I need to know that, is it going to be selling? Is it feasible to sell and start that here? So I need to have the average income of certain threshold value. If it is less than the threshold value, there is no point in opening this, because hardly 1 or 2 people will be buying this. I cannot open a shop for that for the whole year. So I need to have enough estimation. So there is something like if I get enough, suppose I have so my estimate is something like, unless there is something like 1 lakh is the minimum income that I am expecting, average income per month. That is when I will start a shop here, sales unit here. Otherwise, I am not going to start. So, if my theta hat happens to be, let us say, 1,05,000, right? 1,05,000. So, and then 1,05,000. So then, what I am saying is that it is perfectly fine. Maybe the earlier one is correct, whatever. So 1,05,500, let us say. Right? This is very close to this. So I tend to conclude that my hypothesis is correct. There is more than 1 lakh. So therefore I can go ahead and open the shop. Right? Right? So therefore that is where. So there are properties like as n goes to infinity. So naturally, if I take the n to go to infinity in the sense that since the population is infinity, so if n goes to infinity, I can always it goes to capital N. Capital N is the total population size. Right? So if I have this, then my theta hat should naturally go to theta. It should tend to theta, right? It should be closer to the actual. I don't know what is that value, but it should be closer to that value, because I am going to depend on this sample value that I get for all my decisions. Be it crossing the road, be it opening a new shop, be it opening a new course, for example, this institute, etc. This is where we used analysis, real analysis, like different convergence of series, convergence of sequence, all of these we used this. So yeah, in the early part of 1990s, people have spent all these different they developed these theorems, Cauchy's inequality, that's what was used in correlation coefficients and all of that. So this is where a lot of mathematics was used here, developed. And then once it is done, then people started applying it to different kind of applications. So there are different applications in industry. So let's come to that. Please go to the next slide. You may not have too much job, because I normally have a habit of talking 20 minutes per slide. So I'm sure all of us know about statistics. So what is statistics? Anyone? Heard about statistics? Which I mentioned in the morning also, but anyway, let us look at that. Please go to the next slide. Statistics is the discipline that concentrates on the collection, analysis and interpretation of numerical data. Correct? And so what is data science? That at least you must know. It's more current. What is data science? Huh? Sense out of it, insights out of it. So that's correct. So data science, probability. So you develop, that insights, what is going to happen next and all that lies, and probability is the basis of that. What is the, for example, you decide based on what is the probability that certain things are happening, certain events are happening, certain threshold values crossing over, etc. All of this, and making sense out of the data. That's basically what is done, right? And statistics helps the data scientist to design a corresponding experiment to collect an appropriate data, right? And find connections within the data. Like there are relations between, for example, in the morning's scenario I was mentioning, there is a relation between COVID period and the sales, right? Connections between the data. That is where statistics comes into the picture. It helps in identifying those connections and prove correctness of obtained conclusions. Like first, the machine learning throws you some output saying that okay, there is going to be increase in sales the next 2 years. Like what happened is that here is where the problem was. So we have 2018, 2019, 20, 21, etc. 22. This we have the data. So we had sales of this particular product over here, and then in 20 it dropped down a little bit. And 21 and 22, it really peaked like this. And therefore, using this, so what happens is that it tries to identify this your gradient boosting method. I'm sure all of you know about it. In machine learning. In machine learning, there is this gradient boost. So it identifies that step increase, the increase in the step-by-step increase, and looks at that there is a huge increase here, 20%, 30%, 40%. So it sort of projected it here for the future. But then what is happening is that we need to see that we need to correct the data for the COVID situation. So if you actually correct the data, it will come to somewhere here and then like this. So now you see that the increase is not so much like 20 or 40%, it's like 15%, 17%. And then you project it, you may be able. So you look at the difference between this. This is where we need to use the connections between the different variables. Right? In economics, they call it as, for example, dummy variables. They use dummy. But another thing that happens in a retail forecasting is that usually all organizations, if you go today also in any retail company, they will say 20% off, 30% off. There are discounts, there are sales. All these things happen. So say naturally, one of the things that they do. Why do they do that? Why do they increase? Decrease the price? At first instance, why do they decrease the price? What is the need to decrease the price? To increase the sales. One. Another thing is that to sell off your inventory. Sometimes you have a huge inventory because of maybe a competition. For example, a new product is something. If you take Apple for example, iPhone 17, right? So that is taking up all the mobile sales. So that there is an alternative. For example, Samsung has to give some kind of a promotion or some kind of additional features into the product. So they have to bring a new product. They will have to sell it at a lower price to clear that. So there are different reasons for that. So what is the relation? So what are the various factors which influence this? Right? What are the factors which influence this? For example, if you look at the sales, a sales is a function of different factors. For example, let me take a common factor. Plus, let us say V1 into this is the sales at the so let's take sales at a particular time. Sales at T is a function of sales. This is what is sales of a competitor 1. Then you have V2 at competitor 2, X1T, this is X2T, etc. You may have, and this may be the price of the competitors. This is the sales. This is the price of the competitors and so on. So you may have different factors. Now what factor is influencing your product, your sales, is where you need to use a normal regression analysis. You can find out what are the significant factors, you can use it. So if you use a multiple regression, you will get all of that, right? So you can use, that's where you see statistics is useful, right? So you can see that at the end of the day, for data science, for AI, you need to collect the proper data. So which data is influencing, which data are to be collected, again, is something that you have to understand using statistical significance. Then only we can look at it. So let me give you some examples of where all statistics is used in industry. Right. For example, you look at manufacturing industry. So in a manufacturing industry, so you have quality, reliability, warranty. So quality, how many of you have heard about quality? And what is quality? How do you define quality? Yes.
Whether it fulfills its purpose in a good, better, best way.
Fitness for use and fitness for use fulfills its purpose.
Yes.
Performance.
The best way.
Performance. Yeah, best way in the best possible way. Absolutely fine. Anything else?
More shelf life.
More shelf life. That is one of your. Maybe that's a way of evaluation of performance. How good the product remains in the shelf for a longer time, right? So, in other words, what you're talking probably about is longevity, right? Durability, longevity. For some products, longevity is required. Absolutely, yes. What else? What else you can think of? Fitness for use, longevity, huh?
Depends on product.
Dependability, right? Dependability. Right? When you want to use a product for a particular purpose, it could depend on that, right? You know that it will serve the purpose. It will be helping you in doing that. Absolutely. What else? There are 8 dimensions of quality, by the way. Vectors for use, performance, right? Durability, reliability. What is the difference between reliability and durability? What is the difference between reliability and durability?
Durability is less with time. Reliability is better with performance of all class.
Reliability is basically availability at a particular point of time. So I could say if a product is reliable if it is available at that time. So that means it is not failed. It is not, failure is very less. So where the failure is very less, then we say reliability is very high. So there are different estimates like mean time to failure, failure rate, different ways in which we are looking at that. So in the case of reliability, and whereas durability is something like how long it will be available. So for example, if I go to a shop to buy a washing machine, I see 2 brands of washing machine. One is having a 4-year warranty, another is a 2-year warranty. Which one do you buy?
4 years.
Obviously. Now why? Because it is a durable. It is expected to be more durable. And do you think the product is so that is also a quality? For example, when you buy the 4-year-old warranty, your expectation that it will definitely not fail till 4 years. So that's a reliability. So that's how durability and reliability are related. It is reliable up to 4 years, means it is the failure is very less. In fact, usually, invariably, let's come to this. How do people give warranty of 2 years or 4 years or 5 years or 1 year? How do the companies give 4-year warranty, for example? Because the quality, it doesn't fail. So you need to estimate it. So what people do is that they put 100 items on test, right? 100 items on test and see how many. For example, you look at electric bulb. Like you see that most of the products LED bulb you buy, they write that date. When I say 1 year warranty, we don't take that bulb and then see what is the date and all that. They also know that, but anyway, they write it. Why? And how do they come to that 1 year warranty do they give? They have to test it. You have to put that 100 bulbs on test. So then estimate the life of that bulb. How long fan, how many hours does it survive and all of that. So they estimate. But quite, you can now imagine that. If a washing machine, they have to give a 4-year warranty, they have to keep 100 washing machines for 4 years and then see whether it is surviving, how many of them are surviving, it is not possible. So there is something like they have something called accelerated life testing. So they test that equipment at different voltages and they have a conversion rate, transfer function. If at this voltage, if it survives for something like 200 hours in a normal 230 voltage, it will survive for something like 5 years, 2 years. So you have a transfer function. You have that. So that is where mathematics is useful. You try to sort of identify what kind of functions exist and all that. Right? So that is why warranty is given. By the way, all warranties are given for products which do not have not more than 4% failure in that duration. If you are giving a 4-year warranty. In fact, I would like to give a very simple example. There are companies which have, I remember initially when we started IAM, in 97 we started, 98 there was, I think it was Olympics or something which was going on. No, not Olympics, it was the Soccer World Cup, in 98, and they made an advertisement during that time, particularly in Kerala, because Kerala soccer is very famous, I'm sure you know that, right? So they were, making an advertisement that you buy this particular TV this year for this World Cup, you will be able to watch the next World Cup also without any problem. That's a warranty of 4 years. Until that time, all the existing TVs were giving just 1 year warranty. Just 1 year warranty. And there were companies which had to compete with that, otherwise it will not be sold. So they also started giving 4 year warranty. And you remember, what happened? You don't even remember those names of the TV manufacturers now. They are all gone. Because there were 40% failure in that 4 year warranty period that they gave. But for competition sake, they had to give that. So you cannot do that unless you have your quality improved. Right? This is where you need to estimate your own product performances rather than giving any kind of warranty. So, but there is a pressure from the business side, from this one you need. So this is where quality and reliability are given. Another important aspect of quality is, so let me tell you, go maybe a little bit details into that. Okay, so there is this a simple another example of quality is reliability. Is about this. All right. So suppose I am having this. What is this 200 ml water bottle or what is this?
250 ml.
250 ml. Can you take a look at these two bottles and see if the quantity of water is same with this? Right? I didn't produce it, I didn't manufacture it. Any two bottles you take, there will be some difference. Maybe 1 ml, 2 ml, 5 ml, 7 ml. There is variability in any two products you take. That is where statistics comes into the picture. Where there is variability, and why this what is the problem with this variability? What happens in this variability? Now, if it is just 1 ml, 2 ml, it is okay. But if I take a bottle like this, where there are something like 10 ml, 20 ml less, you won't even buy it. You send it back to the customer, right? So the customer rejects bad quality products, right? For example, I say that this is 250 ml butter. Let's take 250 ml. For that matter, let's take a 500 ml bottle. 500 ml bottle, the customer accepts anywhere between 495 to 505. Of course, customer is happy if you give 5 ml water more, right? But you are going to be in problem. Producer's loss. Anyway, producer's loss. 5 ml every bottle you put more, you are going to incur more cost, but you are going to get the same price. So it's a producer's loss. If it is less than 495, it's a consumer's loss, and consumer will reject it. Ultimately, it will be your own cost, right? But some of us who don't have measurement to estimate it, this happens with milk. Every day we get milk, and our people know that okay, 500 ml milk bar. This one you will get 3 cups of tea. And if it is less than 3 cups of tea, then you know that it is less than all that. You complain to the people and all that. So this is what a specification limit, right? And people evaluate how capable you are with respect to their specification. It could be, you can take for example time for completion of service, time for completion of a particular designing a product, etc. So you can have any parameters. There will be always some customers. Sometimes the customer could be internal customer as well. There could be internal customers, there could be external customers, but the customers definitely evaluate you at some point of time. And if you see that if a distribution is like this, suppose I take a sample of, let's say, 100 water bottles, and I estimate the record what is the amount of water in this. I plot it over here. If it is like this, what do you say about it? It's a normal distribution. So is it an acceptable process? Yes, acceptable process, because most of the values lie here, but still there are some which are outside this. Right? So in a 3 sigma process, in a normal distribution 3 sigma process, right? What is the kind of, basically 99.73% of the values lie here. And if it is a symmetric distribution, you have 0.135% here and 0.135% here. Not percent, it's just 0.135. 0.135. Okay? On this side, on this. That means totally 2700. So if I look at it, it's going to be 0.27, right? 0.27. So in this 0.27 out of 100, that means out of 1000, 2.7, and the 2700. So if I look at 27 out of 10,000. So and normally how many milk products, how many bottles do they produce in a day? Even in an hour they produce 1,000, 10,000 bottles, right? So therefore in a day how many do you produce? 27. And it is actually not just the products you produce. 27 dissatisfied customers out of 1,000 customers. They won't buy from you again. Hey, don't buy this lady. Go for Kinley. Because you are having this one. And of course, I am talking about one parameter. But that same water bottle has different parameters. Impurities, for example. Right? That's a different parameter. I am talking about one parameter. So in that one parameter, you identify this. So this is where it is called, how am I compared to? So for example, I take a sample and I get a mu of, x bar of 500 and the standard deviation of, let us say, 100. Okay. I take a standard deviation of 100. This is a population mean and standard. I am estimating that. Of course, mu hat is this, sigma hat is this, based on the sample that I got. And what is mu? And therefore, I am having a sample size of 100. So, what will be my standard error? So there is something like you need to compute because there is a variability that is existing. So if I reduce the variability, I will have something like sigma by root 10. So root 10 is 10, so it is going to be 10. So mu hat plus or minus 3 times 10 will be my 3 standard deviation kind of thing. So which means that I have, essentially this is called a 3 sigma process. 3 sigma this side, 3 sigma that side. Right? So this 2700 parts, how did I get it? 27 parts out of 10,000 because there is 0.3135 out of this, right? So this is because this is mu minus 3 sigma, this is mu plus 3 sigma, this is mu minus 3 sigma. Whereas this mu minus 3 sigma, mu plus 3 sigma is your own process. But this 495 and 505 is specification given by the customer. Customer evaluates whether you are capable to produce that. So if your process is in such a way that if I have another process, if I am able to reduce this process to an extent, the variability is so less. Now you can see how am I more capable now? Compared to this, I am more capable now. This is called a 6 sigma process. I am sure you have heard about 6 sigma as a quality improvement. TQM. At the end of the day, the quality is an inverse function of variability. Wherever variability is high, quality is low. Right? Every time consistently I am producing the same 500 ml in the bottle, I will be passing all the tests. Anybody who takes that, it is not a problem. Whereas if I am producing sometimes 495, sometimes 490, sometimes 505, sometimes 510, that means there is a problem of quality. I don't produce all the time quality. So variability is the issue. In all these examples, any industry problem you take, every problem happens because of variability. Software project, you need to complete it. You have 3 months time. You need to complete it. You have whatever you have this, data collection, available, just understanding the problem, and then converting that into a data into software model, and then identifying, developing the software model, debugging it, and then producing it and giving it, delivering it to the dealer. All these things 3 months. So if you are delaying time for delivery, anywhere it is delayed, that means you are going to be penalized for that, right? So because of variability. If every time you are able to produce within time, then you are not having any problem. The moment you go out of that, so variability needs to be reduced. Correct? And how do you reduce variability? First of all, you need to identify what are the sources of variability. You have analysis of variance, design of experiments. These things will help you to understand and identify variability. Split that variability. For example, any kind of a problem you take, you have variability. You have something like x plus some error. Right? If I am saying that sales is a function of just so usually sales in a retail store like Smart Bazaar and all that depends on if the sales in a particular day depends on how many people come in that day. Because most of the time, gone are the days when we go with a specific list of items to be bought and we buy exactly that. Anyone remembers you bought exactly what you bought? Gone with that? No. And particularly when you go with children, impossible. So one of the this one is that we found in one of our studies we found that number of customers arriving in a center in a retail store is actually a positive function of this one, right? Sales. So we found that during weekends more people come, so more sales happen. During weekdays less people come, less sales happen. So there is a direct correlation. If I try to find out that why is that, and then so using that, one of the there was this Kishore Biani, not Kishore Biani, I'm talking about Biani, who only started this bazaar, big bazaar and all that. I don't remember. Is it Kishore Biani? Not D-Mart. Yeah, now D-Mart also he has a stake in that. So he started this big bazaar in 2005, 2006 and all that. So 2007 January during Republic Day, he announced that kind of a thing, something like a national sales day. So there were something like 2 days, they announced 50% off on all the products, right? So this big bazaar and all the streets, the whole road was flooded with people because what happened was that fridge was, for example, those days, fridge and all was not that common among all the households. So fridge was for 15,000, the normal cost. 50% off means 7,000, 8,000. So even people who can do daily wages, they thought of, they can somehow put all their money and get a fridge or AC and things like that. So they started buying that. And as a result, normally in a sort of, middle income group people come, about 1,000 people, 2,000 people in a day. That day in an hour, 50,000 people came. You can imagine. There is a stampede there. And the police came and stopped that. They closed that. Okay, tomorrow only, all of you come tomorrow. Next 1 week we are going to have the same sale. You come. I don't know how many of you remember that. If you are in Bangalore at that time, you would know. But this is what happened. Why? Because they estimated. There is a relation between sales and discount. So this is economics. Price elasticity of demand. Right? The elasticity of demand you need to understand. How much you can elasticate? Go ahead. If you go ahead, he is opening up for some categories of people who never thought of buying it. So that's what if this is available, it was really becoming a very cheap. Now that's exactly what happened with this Deccan Airways also. I'm sure many of you know what Deccan is. But cost-effective airlines. They gave tickets for 2,000 rupees, 3,000 rupees. So ultimately he had to shut it off. That's another thing. But then it opened up for new people. So you need to see is there a demand for that. You need to estimate the demand, right? And there was proven to be demand, so that it was useful. And then Kingfisher took over that, and all that drama happened, and all those things. So again, what I'm trying to say is that estimation of demand, estimation of quality reliability. That's where statistics is required. And processing industry inventory. Now another thing. That's what I was telling you. Even this whole very example of this big bazaar is also estimation of inventory. So he had to pull out the inventory of whatever he had throughout the country to satisfy this 50% of sales on that particular thing. And in the process, your cost increased. Right? So actually, inventory has to be properly assessed. Where do you keep? So inventory involves several things. Quantity in the shop floor, quantity in the sales floor, quantity in the warehouse, quantity in the what is called as nearby hubs. We call hub and spoke model is there. So which model is more important? Where the demand is more? Now today we have this blanket. What is their main advertisement?
10 minutes.
10 minutes. How do you think one can, in this traffic, 10 minutes you can't even walk for, for 1 kilometer. How do you think they can give? They should have enough hubs, they should have enough warehouses, right? That should be there everywhere, no? So, and that requires investments. That is their model. So they can sell you that, they can sell you all of that. So that requires how much inventory you should have. For example, I'll give you a simple example, matchbox. You need to have matchbox, enough quantities, salt you should have enough. So they need to estimate what are the kinds of products on an everyday basis, how much is in demand, right? And particularly when it comes to summer, when it comes to winter, what kind of products do you have, juice and other things you need to have during summer. So they need to estimate all of that. This is where statistics is required, because no amount of usage of data alone is sufficient. It also depends on this time. Then you need to use a prediction. For example, you need to use a news item which says that this year the rainy season is going to be prolonged. In Bangalore, nobody needs to say that. it is kind of there every time, right? So if that is the case, you need to have rain related products, umbrellas, etc. need to be there in the shelf for a longer period of time. So you need to estimate all of that. This is where, and mobility. You are a Uber, right? During the peak time, you will naturally have more demand. So you need to have more drivers are available for that, more vehicles available for that. So they give a special discount and special offers for their the drivers. They say that if you drive 4 hours during the peak time in the morning, you will be given additional this one. For example, otherwise normally they give something like 30-40%. You will be given 60%. But what they do, they suck the price. What they do is they increase the price. But at least it's available, right? So that is why invariably you better need to book in advance, particularly in a peak time. Like today, yesterday also I booked it in advance. Otherwise I would have been late for this whole session, right? So that is why it is required. So you need to sort of understand where do we search, how do we increase our strength here now. Let's go to the next slide, please. I just give you some example of a typical. Of course, I have mainly, I gave these talks usually I give to management students, but I'm sure managing is something at the end of the day everybody will understand also. So you look at, for example, human resource manager, create and maintain a correct. So what is the role of a human resource manager or something like a HR manager? Have you heard about HR? Human resources. What is their job? To keep the people happy, to retain the people, right? To retain the people, that is the biggest thing, retention, right? So how do they retain? So they need to understand what is actually contributing to their factor of leader. First is maybe salary, of course. And then the second thing is work-life balance, absolutely. The third one is flexibility to work. The fourth one is self-respect, and so on and so on. So you have multiple things, so that the environment should be conducive for them to work. Right? In fact, I have heard some people saying that earlier people are very happy during the COVID period. They are all working from home. Right? After 3 months, they realize that, my God, I am working for 50% more than what I used to work earlier. Right? And now I don't see any colleague. I sit in a room and work, and many times people are bachelors. They don't have anybody at home, they can't go out. And they are working from morning 8 o'clock to evening 10 o'clock. They don't have life. Then they realize that no, this is not going to work, let us go back to work. Right? So, conducive environment, collegial environment is required. In fact, many times I used to say that I have good colleagues, but I don't have friends. Right? Colleagues, you can always talk to them, and they also understand. For example, I need this, I need to talk to some other client tomorrow, I need this thing to be done. They will do it. But that friend, you also, there is a lot of things that is, interaction with different people have a different kind of a role in your mind. The kind of, the mind gets ready to handle anything when you meet so many people. right? That's the advantage you have. Whereas when you don't meet people and you sit at one particular place, you may not. So that is the inclusive. What is contributing to the people's dissatisfaction? What is contributing to the people leaving the company, etc. So again, you need to have that regression model to understand how many people have left, who all have left, what is the reason for that, where they are dissatisfied. It could be sometimes because of a manager. A manager scolding you, they are not allowing me to work from home for some time. They are not, particularly this happens with younger women who have children, no? Just having new mothers. They need more time with their children. Of course, government gives 6 months maternity leave. But afterwards, they may, because in our condition, Indian condition, I tell you today also, when I was in Accenture, I also used to conduct a lot of programs for the, in terms of how to improve work environment, etc. Many people tell me that, sir, even though we do all of, people say that, women working has increased and all of that, every family wants women work. But they want women also only to do all the household work. I have to do my break, I have to finish breakfast, lunch and pack it and give it to my husband, then only come here. And even keep that for my in-laws also, then only come here. This is the reality today, even today. So therefore, how do I involve that, increase that environment, make that more contributing from the company, from the individual point of view, again requires that. Because you need to know what is contributing. Sometimes it's okay, sometimes you won't get a good hike in your salary. But I'm happy with the environment, I'm happy, okay, probably this is the case with everybody, maybe there is a recession that is taking place, I'm okay with that. But as long as I get my respect, I get my job respected, I'm fine, I can continue for some time. So you need to understand what factor is important. If that gets a hold there, next day I leave the organization. Then people have done that, right? So therefore you need to understand that. So similarly, finance manager, you have a lot of portfolios, lot of options to invest. Which option gives you the maximum return of benefit, return of investment, right? Right. We all invest in certain things, some mutual fund, some stock market, etc. How many of you share in the, to stock market? No? So long? No one? Wow, same people. But then, usually, you need to sort of, sometimes, grow your money. So that, and you need to put it in safer investments. Even companies, for example, they need to understand where do they invest money, whether they should, which kind of a department they should invest more money so that they get more, mileage out of it in the sense in terms of students coming in or, other kind of intellectual outputs coming out, etc. So you need to invest on that. So you need to understand that. Again, because the output is a randomness, for example, if you invest the money today, whether it will increase by 10% at the end of the year, how people invest? Looking at the, their current, financial capacity, how many people do they have, what product do they produce, is that product relevant to society, will it remain relevant to the society after 5 years, etc. You assess all of that and then invest. But you never know that it is going to be relevant. We know several companies which have completely vanished, right? All this happens. So it's a randomness, but you need to estimate it based on that. Infrastructure, electric companies need to see how many megawatts of power they should buy in the next 5 years. Right, today, you see that so many malls are coming, so many, the city is expanding like anything, so many people are coming. How many additional megawatts of power do we need to invest? And we know that they are giving free power. So we have to also get free electricity from somewhere. I don't know how do we get it. How are we going to get it? How are we going to give the free power? How long it is going to survive? I don't know. Anyway. So we need to, that needs to be estimated also. And today someone is saying 30,000 per women. Bihar election.
10,000.
Huh?
10,000.
10,000?
10,000 they are providing right now.
Right. 10,000 for all women.
1.5 crores.
Yeah. And 1.5 crore women, 30,000, 10,000, how much is it going to be and who is going to generate that money? Anyway, so I'm not here to campaign for anyway this way or that way. But what I am trying to say is that from a statistics point of view, you need to estimate it.
Estimation.
You need an estimation. Otherwise, you want to land in trouble, like what's happening here. You don't have money to build bridges, which is we started 4 years back, all stopped. Without estimation, you are going to do it wrong. Whatever be the field you are in, right? IT manager, so timely delivery, product development, project management, all these things. Production management, how much to produce, when to produce, what products to produce, right? There are 5 different types of products. right? For example, you can get a water bottle, 500 ml, 1 liter, 250, 200, you have different water bottles. How many water bottles do we need to produce in a day? And which type of bottles that you need to produce? All these things depend on the demand. You need to estimate it, you need to forecast it, and so on and so on. Right? And operations manager, supply chain management. I already talked about the optimal inventory levels, and it also includes how do we distribute to different centers, so there are two kinds of upstream and downstream supply chain, right? Upstream supply chain is from collecting the material, raw material from the supplier to the shop floor. You need to keep some raw materials in the inventory there, right? As and when production comes in, to take it out. So that is why these days people follow what is known as just-in-time systems. I don't know how many of you heard about it. Just-in-time systems. What is the just-in-time system? That if you need to produce, for example, if I have to produce 500 cars in the next month, right? I need something like, let's say, 500 cars means I need, every car requires 5 tires. So I need to have something like 2,500 tires I need next month. So I need to order for that and keep it over in my. So if I need to keep 2,500 tires, I need more space for that. So instead of that, what I will do is that I'm going to start the production on 1st November. So I need this available only on 31st October. So you tell to JK Tires or whatever be the case, I need this much over there. They will keep in their inventory. Ultimately, it is going to come back to you. It's going to increase the cost only. But then, it is you are not, because some products are sometimes perishable. And also one more thing that happens is that these days there is also what is the pilferage that happens. Right? Where something gets lost. Steel, for example. You have tons of steel that is required for car manufacturing. You see that some steel is lost over there. Right? So all these things happen. So that is why people have blockchains. Have you heard of blockchains? In what connection have you heard of? Blockchain. What have you heard of blockchain? Cryptocurrency. Right? So what is blockchain is? Blockchain is basically helping you in supply chain to understand what all the, so wherever you go, there is a tag attached, there is a kind of sensor attached to this. So where, for example, the product starts from, let us say, somewhere in Haryana or Gurgaon somewhere, and then to reach here, what are the hubs it has taken place, what are the places it has come from. If there is anywhere there is a reduction in the weight, reduction in any of the parameters, it will immediately give you an alert. So you can search through. So in the blockchain, what happens is that, in fact, in most of the organizations, for example, McDonald's and all of these guys in US, they announce this. We use a blockchain for our supply chain. What do they do? This is that they are basically buying the food materials, food grains from the direct agriculture. So from where it is produced, you can go and check. Right? For example, poultry farms. Which poultry farm is the chicken brought from? All those things you can identify. So that you can verify the quality of that and all of that. So blockchain helps you to understand the entire chain of the whole. Wherever blocks are there. Cryptocurrency also. Who has transferred? What has transferred? How much has been transferred? How much has been? All these things are essentially identified over there. That's why it is cryptocurrency. It's all recorded. So that is why nobody can cheat. In the sense that nobody can essentially pass it on without any notification. Like people do here, just pass on the cash to somebody. Cannot do that. That's why it has that advantage. So blockchains give you an example of that. And then in a bank, the manager has to identify. How much time do you have? 1:15. We have another 20 minutes. Right. So a bank manager, for example, has to decide about the NPAs. What is NPAs?
Non-performing.
Correct. Non-performance assets. Non-performing assets, basically they give loan. Right? Loan to different things. Like you can also after graduation, you can go and say that I want to open a small startup. I have this is my plan, this is my proposal, and I want so much loan for setting up these things. I want a computer, I want an AC room, I want rent, this much is the rental of that place, etc. You can put all of that and say that this is what I am going to do that. If they have certain list of things where they can approve. For example, there is some MSME and this, that, they have some schemes. Government has given saying that if somebody is wanting to start up a startup on a software project or a defense related project, drones, etc., you can do that. They will give you loan. So they give loans. Then after 3-4 years, maybe 1 crore, up to 1 crore, 2 crores they can give, depending on what is the kind of industry size that you have. right? They give you that. And then biotechnology products also they give a lot of loans these days, right? So you give that, and then based on that, at the end of the day, you see that it is not sold to the customer. But the customer has not returned the EMI for you, that becomes a non-performing asset. So that is the basically you are not getting the return of the investment that you make. It means that the business is not going well. So they assess your business and all of that. You need to estimate whether this business is going to be successful or not. Even for example, if you simply apply for a housing loan, they will evaluate what is going to be. So you say that the housing value is something like 1.5 crores now, right? And then you want to apply for, let us say, how much loan you can get. Maximum they will give you maybe about 1.2 crores or 1.3 crores. They will not give you all 101.5 crores because it is possible that value of the asset may go down to an extent. Possible, right? That doesn't happen most often, but if it happens, then they will lose all their money, right? They are giving you 1.2 crores loan. So if after 1 year you have not returned the money, they can take the possession of that house and they can sell it to somebody and recover that 1.2 crores. If it is stuck over there, that is called a non-performing asset. We cannot get any return on that. So we need to estimate that. In fact, most of the banking managers, above senior managers and all of that, they are under fire if the NPA increases that. But of course, there are people who have gone away with a lot of loans and staying in the UK. All these things are part of our country's culture. That's all. Anyway, so that is how, that is where, so you need to estimate properly whether this person has potentiality to return the money to you, whether the business will grow to that extent. So you need to look at the industry growth. You need to look at the potential growth of this business. Who are the possible customers? What are the possible payment of the customer's capacity, right? All those things you need to understand. Then only you can estimate that. Then the marketing manager, increase in sales and distribution, right? Their main ability is to. So, for example, what a marketing manager does? What is the function of marketing?
Promoting the thing.
Promoting the product, right? Promoting in what sense? So you can promote using different ways, right? One is you can promote using discounts. Another is you can promote using Salman Khan, or using advertisements in TV. That you can also advertise. These days, I saw very surprisingly, Gautam Gambhir is in some advertisement. Even during his playing days, he was not in any advertisement. So, right. So advertisements. So you need to understand what will sell well, which channel you need to advertise, right? For example, for products like your Kia, you can advertise in most common newspapers and other things. Whereas for specific advertisement like Audi or BMW and all, you need to advertise in maybe Economic Times or wherein most business people watch that, or most of the people who require that high-end this one, right? Then you can. So you need to understand, where do I contribute? Where do I put my money, advertisement money? You have something like 1 crore available for this year to increase the sales. How does this happen in a business? See, what happens is that in a board meeting, right? The CEO and all managing directors and all these people, they sit over there and they decide, okay, last year the sales was this much. Like we had something like 500 crores of business we had. We need to increase it to 600 crores. So they will take a decision like that. So then there will be production manager, there will be marketing manager, there will be finance manager, there will be HR manager, there will be all these guys will be sitting there and they will say that production manager will say, no, I can't increase. That means 500 to 600 means 20% increase, right? I can't increase the production to 20% because I don't have any equipment. It takes at least 6 months to buy new equipment or build a new plant. It is not possible. Then they say that, okay, you go for outsourcing, right? So outsourcing, this is how it happens. You go for outsourcing, right? Then you say that, okay, I do. Then increase. Marketing manager says, okay, 20% increase is on me. That means I need at least 5 crore budget for increasing my sales, right? So you take a budget for that and then you allocate to different campaigns. You support, for example, you sponsor cricket matches. That is again another kind of campaign, right? Right? So you have different. So you need to, whether campaigning is better, it will give you. What you need to look for is, where do you have what is called as conversion rate? How many people are actually converting to buy it? Some people see that. We all see the advertisements. It is all very nice. BMW, all that is good, but we don't buy it. So if you advertise in a common channel, 90 people will buy. Of course, the TV channel will say that we have We have, what is that? TRP rate. We have a very high TRP rate. Most people are watching, we advertise at this time. Yeah, see the advertisement, we enjoy it, but it doesn't convert into sales. Where does it convert into sales? Maybe you advertise in NDTV Profit or somewhere where business people are watching, potentially they know it will be more profitable. So which channel to advertise? We need to estimate our time. So that is where we look at most of the time when you look at this Tata Play and all of this. These guys know who is watching what, which OTT you are watching. They will have, right? So you know and how. So therefore they will sort of bring in those advertisements around that time. So if the people are watching who are watching all English movies, all kind of business movies or different YouTubes, then accordingly they will sort of advertise over there. So these are all where statistics is used. You need to estimate, you need to use the data in an insightful way. That's where data science is useful. Am I making sense? Okay, midway through, any questions? Too boring?
So can you explain about the 3 sigma and the 6 sigma? That's something.
Alright, I sort of left it there. Okay, let me explain to you. See what happens is that, okay, let's take this. If I have a mu height of 500, right? It's a centered process, and I have a sigma height of, let us say, 10. Even 10 is really too much because it's 5. So let me take it as so for the time being, let me take 494 and 506 just to give me some arithmetic convenience. So suppose 494 is the lower control limit, lower specification limit. This specification limit given by you, right? And my process, the production process is such that average is 500 and sigma hat is 2, right? So mu minus 3 sigma is this 500 minus 3 times this, it is 494, correct? This is equal to mu minus 3 sigma, and this is mu plus 3 sigma. If my LSL and USL are 3 sigma distance from the mean, it is called a 3 sigma process. And in a 3 sigma process, you can have 2700 parts per million defects. 2700 parts per million defects you can have, which is huge. So therefore, this also another way to look at it is that the process is capable of producing according to this. There is only 0.27% goes out. So therefore, the process is capable of producing. But is the capability very good? Whereas, suppose, let me say, instead of sigma hat equal to 2, I have now improved the process. I have made it 1, sigma hat equal to 1. Or let's say 1.5. Let's take sigma hat equal to 1.5. So, how can you say what is 494? 494 is now mu minus 4 times sigma. This is mu plus 4 times sigma. That is what happens there. You are able to reduce that to this extent. You see here the problem. So here what happens? There are still some values outside. Now here less values are outside. There is very less possibility that something will go out of this value. It is 4 times sigma. If I reduce further to sigma hat equal to 1, now it will be 6 sigma. 494 will be now mu hat minus 6 times sigma. This is this process that I have. That means you have twice the width available to you. So your capability is 2 times more. Right? So estimating the process average and the process standard deviation helps you to know where you can classify. Like, some simple example is silk sarees. KSIC produces Mysore silk. Silk sarees, it is sold at international market. What is the requirement there? 0 defects. How do you define a defect? There could be multiple defects. There could be one particular thorn is missing or something is smelling. You guys know more about it than me. Because recently I had my daughter's marriage, so I visited to some child shop. So I will look at it. So, right? So there are different defects. There are different opportunities for defects. That's what in Six Sigma language we call as DPMO. Defects per million opportunities. Right? So there are different opportunities. So you identify that. So if the requirement of, for example, an international market is that it should not have not more than even 1 out of 10,000 products should not be even defect, that is a kind of a 4 sigma process. Whereas in our market, we can sell it. I'm sorry to say that. We can sell it with a 1 defect, 2 defect, 5 defects. Hey, it's not visible. If you go inside. No, shirts also. Sorry, not only shirts, even shirts also. Right? We buy it at different prices. There are people to buy it at different prices. So, the larger the variability, you cannot sell it to global markets. You cannot sell it to all markets. Lesser the variability, you can sell it to everybody. Your product is so good. Lesser the variability, you can give more warranty. Right? So variability is the key. In fact, variability is the enemy. Variability needs to be reduced. How do I reduce variability? For example, in a silk saree, how do I reduce the variability? That I need to ensure that that weaving process is taking place properly and there is no fluctuation in that. There is no, so voltage needs to be, for example, it is most machine operated, right? So I need to ensure that the voltage. For example, I look at this water bottle example. Why does the water quantity goes less here? Right? What is the production process there? There is a water bottle here. There is a conveyor belt. The water bottle moves. It comes and stands at a place. Tap opens. Water flows for a few seconds, and then it moves. Goes and puts a cap there, and then puts it back and gets out. Correct? Right? So what are the problem? What are the ways in which this particular water, low water can happen? One possibility is that maybe it is not standing there for a longer time, so it is designed to remain there for something like say 10 seconds, and it only 9.5 seconds it remains. That's 0.5 seconds it goes, so that 5 ml water less. So it goes like that. And what is the reason for that? It could be because the slowness of the friction in the conveyor belt, or it could be because of the voltage fluctuation. It slows down the process of this one. So there could be several reasons, multiple reasons of that, right? So all those things need to be identified. Then you use what is known as a design of experiment. You need to collect data at appropriate times to know where the problem is. Sometimes, in fact, recently, I had I visited one of the ammunition factories, a defense equipment manufacturing factory. And there, we found that, people are, the products were in good control, according to statistical quality control, all of it was in good control. But some of the products, when they tested it in the defense, right, in the border, they didn't fire. The bullets didn't fire. So what they do is that they do a testing. Before they take it to the war field, they do a testing. Out of 100 items, so they started testing for 5, 2 of them didn't function. Then they rejected the whole lot and sent it back to this particular factory. Then they started looking at what happens. And then we started identifying what is the reason for that. So that is why this ISO 9000, in all the products you see there is a batch number. You see, there is a batch number, date and all of that. So go back and see what is the raw material used, who is the operator who was operating, right? All that different details you get. The raw materials you may buy from different vendors. Which vendors raw material you are using there, right? You identify that so that you can fix it. So they found that there was a particular vendor who was supplying raw material had an excess diameter of the hole. So because of that, the grip was not coming out. It was going very freely. So it didn't get that force and it didn't fire off. So these were the reasons. You need to identify that. This is where statistics is useful. You need to identify what contributes to the different factors. We use normally what is known as fishbone diagram. Have you heard of it? Cause and effect diagram. Wherein for every reason you have different, for every product, every output, you have different causes for that. The effect is always a function of different causes. So you can go on identifying that. For example, you could so you have a particular output. This output is a function of different this one. So for example, it could be mainly man, machine, material, and what else? Yeah, correct, method. Right? 4 M's we call. So man, of course, the human being. So this could be, for example, supervisor, worker, and so on and so forth. You can have multiple things, right? And machine you can have, for example, the attaching machine, the copying machine, the cutting machine, the vending machine. So you have so many things. It could be different machines. It could be material, vendor one, vendor two, raw material, even the lubricants and those other things that you use in manufacturing, etc. Methodology, like whether you have process one, process two, etc. All those things. So it's called a fishbone diagram. Cause and effect diagram, also called as Ishikawa diagram. Right? So these are the different methodologies that you use to identify. In fact, these are used in problem solving also. Right? In problem solving also you can use that. Right? So in every situation you can use that. So that is where we can improve based on statistics. Next slide. Just want to take one or two challenges. I think we can go on regression. I also already talked about time series forecasting, like one of the things that is 24. Use it. What is the effect of time? There is seasonal effect, there is a cyclical effect, and so on. You can identify all of that. Supply chain optimization. Then clustering and segmentation I talked about. Like for example, there are different segments in a population, right? High income people, low income people. I talked about blue collar workers, white collar workers, etc. So you have different segments. Identify that and use that accordingly. Fraud classification. Now just go back to that, please. This fraud classification is where recently security, data security. Right? All of those things come into picture. If there is someone using a card at a particular order, like suddenly one day what happened, I was in the airport, right? And then I came out and from the airport, then on the way we ate somewhere, and I gave a card. Right? It was around 1:30 or 2 o'clock or something. And I got a message immediately saying that, is that you who have used this card at this time, because it's an odd hour, and in the whole history, you have never used the card at this time. No, fraud detection. Identifying an outlier. What is an outlier? Anything, for example, if I have one particular water bottle which has 520 ml of water, it's definitely an outlier. You have to identify who's operating that, what is the problem, right? You need to identify that. That's where fraud detection happens. By the way, all of these are essentially the same. From my point of view, all of these are data. Some are applicable in finance, some are applicable in marketing. But at the end of the day, it is identifying variability. It's something that comes out of the way. I should stop that production process, identify where the problem is, and so on. Please go ahead. Right? And then there are different issues in industry. So information available in plenty and in desperate manner. Right? All of us know now the data is very free. It is available. It's available in different forms. Some are available in text form, social media data. Some are available in video form, YouTube's. Right? Some are available in the data form. So we need to look at, identify, quantify that, convert that into the data, analyzable data. Right? That is how that is a challenge that we have. Most of the times we have that challenge. Extract useful information from available data at different locations, because different locations contribute, different story about the data. At the end of the day, what we want to do is that, what is the story that the data is telling? We need to analyze that. For that, we need to convert that into this. So combine data and information with business insights to recommend strategies. And most of the time, it needs to be real time. Right? It needs to be real time. Like for example, I was talking to the professor also in the morning. So we did a prediction of failure of oil wells, oil pumps, right, in a oil company. Right? So this is so where we had used the different data. So they have different sensors. They have the there are some physical data about the kind of material components in that, washers and this, that, all those things, and also the sensor of the that is kept in different places in the well. So then we had a huge data. So we had to predict it using all of this, and then we said that. What they have said is that usually currently it's an offline process, and if there is some well which is a pump that is not working, they stop that and then they repair it. It takes 1 to 2 days to repair it because they don't have parts availability, etc. It has to be brought in and all that. And one particular day of production of one particular oil is something like about $100 million. So they want to look at, even if we can do a prediction in 1 hour, we will save something like $90 million. So we developed a model for that. We use machine learning, we use a lot of statistics over there, using regression, using scatter plots and other things. We found out some factors which were triggering. As it is going up, it is actually leading to the failure. We found out the connections between different variables. And then we found out that we could give a 98% prediction within an hour. So 2% is the error that we had. 98% prediction we could make, and they said that okay, this is good, but only thing is what we want is that an alert has to go to that well managers there. Each well managers has to go there. So we use the mobility. We use that sending the messages in mobile to the managers over there, so that they immediately know that they can keep the materials ready, replacement and work. Even mechanics, they keep the mechanics ready so that they can look at it without much waste of their time. Within 1 hour they could repair it. We had a sample and we just took about 20 wells and we predicted that, and then now it is actually applied to different other. So real-time prediction is important. Right, let's go to the next slide. Yeah, this is the slide I wanted. Now you see here, this is about the warranty data. Right? So you see that here what happens, first 20 months there is we have some parts, car, it is about a car. Like clutch wires for example. We keep changing it, and what happens is that there are some warranty, 24 months they have, right? So what people do is that up to 20 months, the normal thing, whenever it goes off, you go and repair it and all. But during these 4 months, 21, 22, 23, 24, it suddenly peaked. So I have a problem because one of the problems that we were facing is that one of our competitors is giving a 3-year warranty. So our management is now forcing us, should we also give a 2-year warranty, 3-year warranty, from 2 to 3, can we go to 2 to 3. So we need to estimate how much will be the additional failure that happen, so that we can estimate how much additional reserve fund that can we keep, warranty reserve fund. It's a practical problem, right? So what we did is that I tried to analyze this, and I found these things which are very disturbing to me, because if it happens like this, the gradient boosting method will take me somewhere here, which means that 50% of the items will fail in next 1 year. I was not sure about it. Then what I did is that I tried to look at, so we had an interview with the service people, and then we found that, sir, this is not anything so high. It is not that 23, 24 months suddenly the part fails so huge. It's because people postpone. After 18, 19 months, even if some part fails, they keep continuing with it because they know that 24th month anyway the warranty is there. If I go there, I replace it at that time, it will come for a longer time. Why should I buy now? Now this is the phenomena that is happening. So I need to correct it. If I don't correct it, any AI intelligence, machine learning model would give me a very huge figure, which will say that I cannot increase my mistake. So then we corrected that. We brought it down to this and then predicted it. Then we are able to sort of predict it. These are practical problems. So we need to always understand what is the reality. One thing is that we need to understand the domain. We need to know how do we convert that domain knowledge into data. That additional factors you need to bring in here. Right? Another example I can give is that during the time 2008, there was an economic recession. I don't know how many of you know about it. 2008, there was an economic recession, right? Globally. Right? So what happened during that time? Many of the first of the companies which are affected are the manufacturing companies, particularly car manufacturing. So GM, for example, filed bankruptcy. I'm sure many of you know this. Why did this happen? Because till 2008, 2006 or 7, they introduced something called a hammer. One of the trucks, they call it trucks, which has a huge boot space. They have an additional segment for boot space and all that carriage you can have, and so that was going very well till 2007 or so. So they produced. They opened a new plant and they started producing much. And so in America, people have a habit of traveling across America because the public transport is pathetically low there, but it's not there. So they all use cars to travel, even from what you call as Wisconsin to Chicago, to San Diego, San Francisco, everywhere they go by this one car only. So a lot of people buy that, and every 3-4 years they keep changing their new cars and all. So this way it was happening. They invested a lot, but the economic recession happened. Sales came down. So their entire money is stuck in the market. They had to file bankruptcy. Literally happened. Right? Why did this happen? Because the people's I mean the estimation went down because there is certain scenario is not there. So you need to sort of, maybe at some point of time, that is where this, partial differential equations, wherein you come up with kind of a, in a smaller region, whatever trends that you are seeing there, you need to magnify that and see how it goes to the future. So you need to bring up that. In 2008, this kind of things happened in all. So therefore, we need to observe. Here again, you see, for example, during COVID time, there are certain products in the which got increased. I mean, surprisingly, in US, the what is that? Tissue paper sales have increased like and went out of market. I'm sure all of us know heard about it, right? Tissue paper went out of market because the demand was so high because there's going to be a what is that lockdown, we cannot buy it, so people bought. Lot of hoarding took place, not only in every product, all food products, people bought in bulk. Their whole room was full of groceries. Right? This is how it happened. So therefore the demand estimation becomes very, very difficult. And you need to understand certain factors, maybe introduce some maybe reports from the latest reports from the magazines and interviews that are taking place, all of those things you need to know. So that is why I say information is available in different sources. You need to combine them, put it into one particular sheet to sort of do the demand estimation. That is very important. That is how all these things, warranty, everything comes. Yeah, next slide. Maybe I don't have too many. Next slide, let's go to the. Yeah, okay, I think we've already talked about it. So what is the role of statistics in the AI era? So I think we already talked about machine learning and deep learning, while they try to understand extract the non-linearity and all of that, but we need to bring in a lot of explainability to those factors. But we need to bring in a lot of insights into that by looking at what is happening around. I gave you an example already. And leverage data sources to frame relevant questions that are estimable. Like many times what happens is that, so you can ask, for example, the previous graph that we showed, you see that is this trend so huge? You need to estimate it. If you don't estimate it and still try to predict it, then you are going to be wrong. So the estimation part is very important. That is where statistics come. Inference has to be properly used over here. Understand random component in data. What are random components? Like this, for example, global economic scenario, economic indicators. These are all, some kind of randomness. You need to think in how much we can estimate it and so on. Quantifying uncertainty, separate signal from noise. Right? For example, that sales increasing, or that parts demand for that replacement of parts, that clutch wire that I told you is increasing because of a noise. It is not a signal. So you need to separate signal from noise. Right? That is why people use what is known as signal to noise ratio and all of that. Distinguish between causality and reduction. This is a major important contribution of statistics. Causality. How do you improve causality? Right? One simple example I can give you is that sales of fans increase during summer, sales of ice cream increase during summer. Both of them increase. Correlation is positive. Is it causal? No way, right? There is no relation between this and that. But what is the common factor? The temperature, summer. Correct? So you need to understand. So causal factors are to be understood. What are causal? What is causal? Every relation need not be having that causal relationship. So you need to understand that. That is where again you have to go for use of statistics. And then we need to have responsible aids, explainable aids. These are some of the contributions. Yes, I think that's it. Any questions? Agree, is it?
Can you give another example of causation and correlation?
Causation and correlation?
Yeah, one more example.
One more example?
No, we understood. I want an example from real life.
No, this is an example I give in my class.
Which is that?
It's actually a well-known study in Sweden. Actually, they found that ice cream sales and skin cancer were positively correlated. So, same example, I mean, it's just a illustration. Because what happens, because it's a cold country, summer people go out in the beach and tan themselves, so they get more skin cancer. And of course, they eat more ice cream also. So, when more people eat ice cream, so skin cancer doesn't.
Exactly. Both of these have a common factor is that it is the temperature.
Yeah, yes.
So that's what it is. Yeah. Any other question? All right. If not, thanks so much. That's it.
Thank you, sir, Dr. R.P. Suresh. Now let's break for a lunch. Lunch is arranged in A block atrium. Please assemble back at 2:15.
Thank you very much, sir. I think the session was very knowledgeable. I hope our students will use it for some practical usage. So that is a requirement as such. So I hope at least you use whatever the theoretical knowledge what sir explained to doing some projects. Thank you.
Good afternoon, everyone. Welcome back after lunch. I hope everyone had a good lunch. We now move on to the second session titled Data Visualization Using R. So this session will be led by Dr. Sutish Kumar, Associate Professor at the Indian Statistical Institute, Chennai. Dr. Sutish holds a PhD in Statistics from Cochin University of Science and Technology and brings 15 years of academic experience and research experience. He has previously served University of Hyderabad as a visiting professor and City University of Hong Kong and Michigan State University, USA. He is the recipient of several prestigious awards, including Dr. C.R. Rao Gold Medal in Statistics 2021 and the Jan Timbergen Award in 2009 from the International Statistical Association, Netherlands. His research interests include mathematical statistics, survival analysis, reliability analysis, and empirical likelihood interference. He has published widely in reputed international journals and co-authored the Book of Ranger Nature. We are delighted to have Dr. Sutish with us, who's joining us online on Microsoft Teams. So I shall hand over to him and we shall start the next session. Over to you, sir. I hope you're audible. You can speak now.
Asking to unmute and Sir, you're calling me? Please ask him to unmute and start.
Sir, good afternoon, sir. Sir, your voice is not coming clear. You can unmute, sir.
Okay, my
Yes, sir.
now,
Yes. Yes.
yeah, actually my mic is also not mic, video is also not coming. I don't know. Yeah, I will try to join again, okay?
Screen.
He left out. ಎರಡು ಅಲೋ ಮಾಡ್ತೀವಿ ಎಕ್ಸ್ಟ್ರಾ ಚಿಕ್ಕ ಎಕೋ ಆಗುತ್ತೆ ಸರ್ ನಿಮ್ಮ ಮೊಬೈಲಿಂದ ಜಾಯಿನ್
Yes, sir. Audio is coming and screen, you can share some screen.
Share option. Yeah, prefer to support to share option.
No, sir need to share that.
See, I want to join from another computer also, so that I can share some of the things.
Yes,
Sir, hello, sir.
Hello.
Sir, hello, sir.
You can admit it. Okay?
Yes.
Yeah.
Yes, sir. Yeah, now it is visible.
Hello, sir. Are you able to hear me, sir?
Yeah. Yeah. I am fine.
Yeah, you can share your screen and start, sir.
See, I normally use Zoom or what is that? Some other things.
Microsoft Teams.
Yeah, now it is coming, sir.
Coming, sir.
Yeah, I saw that.
Yes, sir.
Coming, sir. Now.
Everything is fine.
Hello, sir. We are very happy to have you as our resource person for today's event. Hello, sir.
Yes.
Yes, sir. You can start, sir. Thank you so much.
Yeah.
Can you please increase your volume, sir?
Yeah, I will. Once I start talking, it will be. You will hear. Don't worry. See, it is not easy to do this things online, but my point here is actually two things. One, in the first few minutes, I will talk about why we need this job. Okay? So then maybe we can talk about the some implementation later.
Is it audible? You can come and start.
So
Okay, call him over the phone and explain what is happening. Because he is probably in the second slide.
Okay. So this is my plan. So why we need that? That is the question. Yeah. This is the main thing that. Hello. Okay, I don't. Is nobody knows anything about this? Let me.
Okay, sir. Okay, sir. Yes.
So why data visualization? That is the question. So there are several aspects we use that mainly help to summarize complex information into understandable graphical representation. Suppose some client come to you and ask you to analyze some data because they want advice for example, they wanted to increase their sales, they wanted to start some new product. So if you can advise them with the help of the graph, then it is easy for them to understand. That is why we use this graph in mainly in reports. And in analyzing also, we use this graph where, yeah, this is what it allows to identification of trends, pattern, and outliers, so that one can decide how to proceed further. So these are some of the uses for these graphs, and one can also use for model diagnostics, interpretation, analysis, and other places. And even if you wanted to use graphs for principal component analysis, one can use some screen plots. So in statistics, if you are coming across different scenario, we have different graphs. So I will discuss with that first, and then talk about. Okay, I will also talk about little bit how to make use of the help in R to plot the graph yourself with the help of means without any help from any other sources. So that's why we will conclude this talk up to 3:30 now. Yeah. So normally we have this. These are the some of the library we use for this graphics, mainly ggplot2. After this introduction of ggplot2, you can see that the graphics in R become very powerful. So these are some of the things I will be using, but I will skip here for some time. Now, suppose you want to use some parametric test. Suppose you want to do some parametric test. So what are the tests we use? So we use some several tests like independent t-test, stability test, ANSYLA, or some other parametric tests, classical tests, set test, all these things. So if you want to use this classical parametric test like t-test or set test, we have to assume something. What assumption we should make? One important assumptions on distributions. We need to assume that the data generating mechanism is normal, isn't it? So how to validate that assumption? Using graph. That is the first things we normally use in analysis. So I thought I will start from there itself. So what are the graphs we use for that? So normally we use histogram, isn't it? Yeah. You can use this type of histogram. So if you look at this data, if you look at this graph, what you feel? If you look at this graph, what you can tell?
Normal distribution.
Yeah, this is something like a normal distribution, isn't it? So one can assume something like that. But if you feel dependent, for example, I generate x is equal to r p. I will show you some other graph. Oh, sorry. We are not on histogram. So what is this graph showing? This is not normal, is it? Yeah. So the histogram and QQ plot. You can also see the QQ plot here. These are the two graphs we use for validating the assumption of the normality of the data. So if you want to use any classical, means classical test like t-test, z-test or ANOVA, we want to assume that the data comes from normal distribution. One can use this means QQ plot, and maybe here if I instead of exponentially, if I generate from normal distribution, for example, x is equal to r norm. You can see that this is a we have a QQ plot. I will explain you more detail what is this graph tells you and how we are plotting all these things after some time. So this is the, you can see that here the sample quantile and theoretical quantile, that is the QQ plot. So this agrees here. You can see that. And here also, if you plot the histogram, it's a perfect normal. So looking at the histogram and QQ plot, one can validate the assumption of normality. So this is one very important graph which we use in statistics. So then if sometimes graph may not give a good result, in that case you can go for some test for normality. So this is about the test for normality. Now we will come to some other plots. I will then explain. So these are the packages we have to install. I have several programs written which is used to teach our students. I can share to Subramani all these programs. Anyway, nowadays we have a lot of resources. Yeah. Starting with the again, histograms are used to visualize the frequency distribution of a numerical variable. They help identify skewness, modality, and spread of the data. So as I mentioned, this is very useful to validate the assumption of normality. Okay, so this is what. So you can see. I will need spend some time here to explain. See, in the GD plot, we already have this data. You can see that we have some data from using this one. And then in the GD plot, this is the usual style. You have a data, then AES axis. Then here you can tell a different thing. G0 of M is the basic M, and then histogram and some other things. So all these things, it is in the initially you feel a little bit difficulty, but once you started working with the ggplot, it is very useful. And one important thing with the ggplot is that if you wanted to plot some interesting functions which is used in your research, one can use ggplot to plot that functions. So it will give you a very nice support. So, so the basic structure, as I mentioned, you can see this is the ggplot, and then then you have to give the data. I here stored df as the data, then AES plus and whatever you want here basically. So I will give you some interesting web page so that you can you can study this graph yourself. So now, this bar chart and pie chart, where we use bar chart and pie chart. Yeah, actually for reporting only we mainly use this. Bar chart and ideally only in scientific agencies, but I have not successfully done this much categories. So you can easily show them so that people will understand which many have more than scientific type. For example, if I show this spike, you can see that. So this is we have a category ABC. These are the percentage of 1% will be something maybe better. Yeah. So you see. Hello? Lot of noise is coming. Hello?
Yes, sir. First one.
Okay, sir.
Go ahead, sir. Go ahead.
Okay. So this is what. So you can see that we can. You looking at this pie chart, one can easily identify how many members from group A, group B, and group C like that. So that is why we normally use this to describe the demographic features of the person which is participating in some way or some study. So one can also use this type of description, some other descriptions also. Pie chart will give you a good understanding. So now, then you can use also bar chart. What is the difference between bar chart and histogram? In histogram, we use the continuous data. In bar chart, we use discrete data. Okay, so that is the difference, and one can also see here. So this if you look at all this graph, you can also see this the structure is here. Structure will be same. Yeah, we have the GG plot, then AES as I mentioned, so you have GOE. So this is what always the structure, GOE bar. You can see here, GOEM bar. So as I mentioned, we have the GG plot, then the data, AES, this is the structure of all this graph. So bar chart and pie chart we can use for this purpose, and then we have another important graph which we used in statistics is the box plot. Did you come across with this plot? Box plot. First we'll see how it looks like. Then we'll come back. Yeah. This is the way it looks like. So what is the box plot and why we use this box plot in statistics? When we use this box plot? A box plot is a graphical summary of a numerical value showing its central tendency spread by outside. You can see that the box shows the interquartile age contains within 50% of the data. The line inside the box marks the median. And then you can see that if you look at this, you see there is a line is there. So this is actually if this line, if the points are actually above 1.5 IQR, then we say that this data is outlier. You can see here one outlier in the first case. Taking time. Yeah. So this is the idea of the you are not seeing that now something happened. I was hearing, but it's not coming.
Coming some bar flood because
No, this is only this plot are not coming out. So you can see that, but here I am not seeing. You can see the slide moving.
Yes, sir. We are on slide number 8, violin plot.
Okay. But why I could not see?
Oh. I'll accept that.
Okay, that's fine. I will. Okay. Names probably I won't use this what is that T. I think not understand. Okay, now if you see the violin code, it is almost same. You can see that it is based on density. That's all. Yeah, actually, I use this box plot also inside. Maybe one can delete these things if you want. So you will get a different graph. Where we use these things mainly in analysis, where we use this. Yeah, this is one of the very means most popular plots used in analysis. Suppose I wanted to go for group difference. For example, I want to see whether there is a difference in the mileage of an automatic car and a manual gear part. So you actually interested to see the difference in the mileage. So looking at this type of curve, one can get some idea before going to the analysis. So if you look at these things, what you will tell? What do you tell? Both the means are equal. You can explain like that. Both the means are equal. So this is what it gives you.
One data set has an outlier, sir. Another data set has no outlier.
Yeah. Outliers is there, but that's you can also find use this to detect the outliers. Of course, simple scatter plot also gives you an idea if you have an outlier, but this is also we can use it for purpose. Now you have a box plot and violin plot is there, and then of course you have a scatter plot. Then this is what this is a QQ plot. So I will explain how we actually get this QQ plot, because if you want to draw a QQ plot for other distributions other than normal, so then it is not easy. Means QQ plot for normal distribution, there is a ready-made formula is there. Suppose you want to use this for other distribution, then how to plot it? That is the question. So you can also use a ggplot here. You can see that where we actually, if you see QQ norm is the last one, and then so this is the way we actually using. I will see first how it looks, then I can explain it a little bit. Oh, we have. Yeah, this is the graph which we have. So this is, you can see that we have a sample quantity here and a theoretical quantity here. So what we plot? If sample quantity and theoretical quantity agree means pole should be in the 45-degree line. You know, y equal to x. So that is why we expect that the pole should lie in this line. So now the question is how to draw this graph. So normal, you have a very simple command, QQ norm will give you. But the question is how to use QQ plot for other distribution. For example, you are doing some lifetime data analysis, you wanted to see whether the data comes from exponential distribution. So you want to draw a QQ plot for exponential distribution. How to do that? So this is what okay. How to do that? So we have, you can see that this y-axis is the sample quantity and here this is the theoretic quantity. In sample quantity we plot the order statistics. And in the theoretical quantity you plot the theoretical quantity which is given normally by f inverse of I by n. F is the cumulative distribution function. So we can plot here f inverse of I by n. In some cases, instead of plotting f inverse of I by n, people use f inverse of I minus 0.5 by n. This is something we call a correction method, but you can simply think that here this is a sample quantity, this is the order statistics, and here f inverse of I by n. If you have any doubt, you can ask me. Okay. So this histogram and QQ plot and box plot, these are very useful in data analysis rather than representative or report writing. This will help us to help in analysis phase also. So we have a histogram and QQ plot to identify the or to validate the assumption of normality, and we have box plot to see whether there is any difference in the mean. Looking at the box plot, one can see whether there is a difference in the mean. So now these are some of the tools, and then we have a density plot. Density plot is actually simply a density plot where it works is actually helpful. Suppose you wanted to use some parametric inference. In statistics, if you know the data generating mechanism, that means you know that data comes from normal distribution or exponential distribution or some other distribution. Parametric inference gives very good result normally. So if you want to identify the distribution, sometimes the density plot also will help you. And suppose you suspect that this is not come from one particular distribution, it may be some mixture of two distributions, then that type of problem this will help us. For example, I will show you the density of plot of this mixed distribution. You see, okay. So if I am using here instead of x2, x1, 1 itself, what will happen? You see, this is a not a binodal. Now it's one from one distribution. See, so density plot also gives you some idea about the distribution. Here, as I mentioned here, you see, now we are considering a mixture of distributions. So, see the graph. It is different, isn't it? So, that type of idea we get using this density plot. So, there are several other plots also there in statistics. You can use the line chart. Normally, we use the line plot to see the time series data. So, if you want to see the time series data, people use the line plot and to see whether there is a seasonal effect is there or some trend is there. All those things can be identified using a line plot. So, and then we can also combine the multiple plot Suppose you wanted to combine different floors, then we can use yeah, anyway, you can use this command. Command can be used. So that I will summon the same matter. Yeah, I am now stopping for this type of description, but I will head now go to the R and teach you how to make use of this R. These are some of the nice things. As I mentioned, setting the right type of visualization for your analytical question is essential. So if you keep this visual simple and interpretable, then your client will be happy. So you can use graph as much as possible to describe your findings, as well as you can also use this graph to convince the analysis. So this is what that is what I wanted to tell you. All these things actually one can use ggplot. That is a more beautiful graph. So if you have any question now, I can answer. Then I will go to the RLP related to data analysis and graphics. Okay. Any question? So then we go to the R. So we will see first the basic R, how to use some of the commands in R to identify. Suppose you wanted to draw a field. Any question?
No, sir, no, sir.
So suppose you want to draw a 3D graph, for example. Nowadays, okay, you can get a ChatGPT, but now suppose you have there are some interesting aspects are there in the R result. You simply put first PRST demo first, then you put enter, means press enter, then again you press enter. Now this window will come. So now you see we have a 3D graph. So again press enter, you will have different types of things. You have a different graphs, you can see that. Suppose you want to draw this type of graphs, you can see that the program is written here in this left side. So simply copy and paste. I will show you one graph. Yeah. For example, suppose we wanted to draw the 3D graph. You press demo first, Then this one, as I mentioned, and then you can see these things. And what I will do is, I will simply copy these things. You just copy paste up to these things. Okay, copy. Now I clear it and press enter and escape from these things, and then you take a new graph, new script, then paste it, and then remove this thing. See, this is what you do. You can also use R Studio instead of R. See this picture. Now suppose you wanted to change your function. Maybe I put some file here. You simply change the function here. Okay, so I can also change these things. You see what it is. So if you don't need to study, you can simply go to R and take ahead. You can experiment with it. Gives you a nice graph, you can see. This is available in R itself. So what is the command we want to use? Demo PERST first. So you can also draw this type of graph also. Okay, for example, we try to use it. Suppose we try to use because somebody working in large company, this type of graph will help. So this is one helpful command which we can use in R. So this is what demo. Again I am repeating demo PERST. Then you have to press 2 times enter. Again you are pressing enter, you can see all these things. Now you can have a lot of shortcuts in R. You can see here help console. There are a lot of shortcuts we use control L, control A, B, all these things. So you can see that. Control L will clear the console. I am clearing every time. So control L I am using. So you can use this R command, make R itself to grow a nice graph like this. So this is the first. So now you can also use demo graphics. You see here also we have a lot of several types of graph are there. See. Pie chart, note. So this is a Brownian motion. If somebody is working with Brownian motion and you want to draw this type of graphs, that also helps us. Of course, nowadays you have different AI tools for that. It will give you ready-made codes. But you can see that if you suppose you are not you are at home, internet is not working, you can use this thing. Yeah, these are so this is what we have. The way graphs are there and these things. One can experiment. What is the command I am using here? Demo graphics. So we have demo graphics is there and we have demo. So now this is, so if you are interested in graphical parameter, then simply type a question mark and then question mark and PAR. So then you can see that you will get all the graphical parameters. How to make a graph more beautiful. You can see this. This is a very big list here. Suppose you wanted to make a what is that different style, different axis, everything is here. You can see that CS axis, LT1. The line type. You can see 0, 1, LTY. You can at least find something. For example, float is now maybe histogram. I don't know why it is. So there are anyway there are some graphical parameters are here. So X Y is square. That is better. Now it will change to some difference coming, no? This is the Ramaiah. The small difference is there. You can see now. If I am using 1, 2, so what I'm saying is Using this PAR command, you can find out all the graphical parameters. Suppose now I want what is x1 x is equal to r1 maybe I want both the cubic plot and histogram on the same plot. So what to do? So you can see that there is no next if you do you will know so I want both these things. So you can use one command called par mfo. You see this same language. So that is for that command we use this par because this type of organization is useful when you deal with the time series, because in time series the modular identification normally especially in bonds and Jenkins, the approach we do using ACF and PACF. So it is better to load both the autocorrelation function and the partial autocorrelation function in same platform. So that is why this is also important, making combining with graph. So here you can change this param is equal to 2 then it will give you 4 into 4 kind of something. You can see that. This is it. So this is about the combining the graph. So yeah, these are some of the things. Now so using help from R, this is some of the things we can use. So now I will show you an interesting website. You type R, QUICK. Yeah, this is a very nice website which gives data or you can see this or this one, static methods. So click R. So see here we have graphs here. You see they are giving different graphs. Simply copy paste and there are some description is also there. Okay, graphics in R. And then we have, as I mentioned, we have advanced graphics also there. So this is a very nice, not only graphics. So you can also learn data analysis using this, data encode, data management, everything is there. Data input, data management, statistics, advanced statistics. So we have data management, statistics now. You can see what are the things available. All these things are available. This is a very nice website for graphics and other things. And I will also show you one website that is useful for data analysis, UCL website. This website also I can use for different purpose. You can use the Uniform University of California. So this website actually very useful for analyzing art. So it is down for some internet is slow. I don't know. I think this website is down. So these are some of the things one can use it. I think there are 10 more minutes. You can ask questions. Not only, so I have some actually. I have certain program for, there are several programs I have. But see, this online is little difficult to make that much. This GG code, if you want, I can share this, all this things. How to make the title and axis. I can show you. Different style making. You can see that. Here. So, this is what multiple graph I mentioned. Page. There is some. Oh, this is not installed. That is why this is not working. But anyway, you have several programs are to box or how to make a legend. There are several modifications one can do this. Plot theme legend using this. To change these things so you can see that what is the difference. This is the you see it is coming in the here. So you can experiment like this. So the line will go up. So wherever you want, you can keep it. So there are several advantages there for using this GG plot rather than this box plot. I think I can stop here. You can ask questions. Not only now, you can ask data analysis. So only 5 minutes we have. This is giving functions. We are using not down some functions. See, now you are changing the directions. So, several way one can think. That is the beauty of the Gigi process. Okay, let me stop here, and if you have any questions, I can answer it. And trying to use this graph not only in report, use graphs in analysis. Report in the sense that normally people use the graph for descriptive description. Rather than we can also use this graphs for analyzing the data so that it is easy to understand. So as I mentioned, histogram and q report we use for validate the data, whether the data comes from normal distribution, and this what is that box plot one can use to see whether the group difference is there, like that. So of course we use ACF and PACF in identifying models in Brooks and Jenkins approach in time series. So there are several ways one can use these graphs. Anyway, I think I will stop. Nobody any question or comments?
Hello.
Yes.
Sir. So there is no questions from the audience. So thank you very much, sir, for your wonderful lecture about the data visualization techniques using different graphs and the various resources also we have shown. So we are very much thankful for this one. So our audience may get more insights about the R programming. Especially this R programming is a open source software, so anyone can download and they can try that one using that whatever you have shown that data camp, this later websites. So we are very much thankful, sir.
Even we can one should try to use the help R pixel to draw some graph, as I mentioned earlier.
Yes. So officially we are closing the first day workshop sessions. Okay, thank you very much, sir, for your lecture. Okay, so everyone.
It is online lecture.
Yes, sir. Yes. This is a problem. So definitely we'll see in the future offline lectures, sir. We have in the future we have plans are there. Definitely we'll do so.
Okay.
Okay, thank you, sir. Thank you very much. Okay, so for today we'll close here. So tomorrow exactly by 10 o'clock our session will start. So please be 5 minutes before only 10 o'clock exactly. Thank you very much. Okay, so outside tea biscuits are there. Okay, so and after that, so and tomorrow when 10 o'clock is have prepare like that you can try. So all you register in the